Yes, good afternoon to all. It is my immense pleasure to welcome you all to the sixth and last day of the AICT sponsor ATAL 6-day online faculty development program on transforming industries with AI, deep learning breakthrough and real-world applications, organized by Department of Computer Science and Engineering, SRM Institute of Science and Technology, Ramapuram, Chennai. It is my privilege to welcome our esteemed resource person for the day 6 and session 11 of this faculty development program, Dr. M. Janaki Meena, and I feel honored to introduce her. Dr. M. Janaki Meena is a highly accomplished academician and researcher currently working as a professor higher academic grade in the School of Computer Science and Engineering at Vellore Institute of Technology, Chennai. With over 2 decades of experience in teaching and research, she has held esteemed positions in premier institutions such as Mufkoshilang Engineering College, PSC College of Technology, and Velammal College of Engineering and Technology before joining VIT in the year 2014. Dr. Janaki Meena's research expertise spans across domains like deep learning, data science, and machine learning, with notable contributions in enhancing programming skills through intelligent online learning portals and developing innovative systems for question paper generation and answer evaluation. She has successfully led projects funded by reputed organizations, including a project worth of 1.37 crore on intelligent teaching learning platforms, and has played a vital role in FDPs promoting emerging technologies aligned with national initiatives such as Make in India and Digital India. An adjunct professor at the Freerom Institute of Technology, Cambodia, Dr. Janaki Meena has delivered courses on data science and machine learning. As a NVIDIA University ambassador, she has been certified to conduct workshops on cutting edge topics such as deep learning and natural language processing. Dr. Janaki Meena has authored and reviewed books, including the publication Theory of Computation, and her research work has been featured in leading journals. Her recent publications include studies on hybrid sentiment analysis, fish classification using deep learning, and underwater image enhancement. Beyond her academic pursuits, she has extensive consultancy experience, having led corporate training sessions, ERP development projects, and innovative software solutions. Dr. Janaki Meena's dedication to advancing education and research continues to inspire students and professionals alike. Her vast expertise and contributions make her an invaluable asset to the academic and research community. Kindly join me in extending a warm welcome
இல்லடா இப்ப என்ன பண்றாங்க
to Meena to our faculty development program and invite her to share her insights and inspire us with her words. Welcome you, ma'am.
Yes, well, thank you. Thanks for the introduction. We should start the session now.
Yes, yes, ma'am.
I can
Wait,
share the
I will,
screen.
I will make you as a host, then only is possible. Wait.
Yeah, good afternoon. So in this session, we are going to discuss about what is explainable AI and the ethical considerations that we have to make when we are going to make a AI system, right? Now, everywhere the buzzword is AI. AI is not a new field. As we all know, AI has its origin since 1950s itself, right? When people started to think that we have to build a system that will assist human in doing the task. And initially, when we look at the systems, how they did was people who are working on that particular field used to represent their knowledge, right? Initially, it was like rule-based systems. They developed rule-based systems, and they formulated the rules for the system, and the system was basically running. Like ELISA is the first program which became very popular for medical diagnosis. As we all know, people used to give symptoms of the disease what they have, and it was giving the answer, right? So it was very clear how does it work. So human had a control over it also, and they can specify in what way it has to assist. So human had a whole control, and AI was just assisting. And then they were trying to make it extend AI systems for more applications, right? Like when we go for rule-based system, it is not possible to enumerate rules and develop even bigger systems. Like when they want to create smaller games, right? It was not possible to create some smaller games also by just enumerating the rules. So then people were thinking how to make it. At that time, machine learning became very popular. So machine learning techniques like mathematically they use calculus, everything, and they were coming up with different algorithms using probability. Also, we got naive Bayes algorithms, right? And we got linear regression and SVM. Those algorithms were evolving, and at that point also, it was very clear how the algorithm works, right? We were able to reason out how the algorithm works. It will work for this type of data. Some clarity was there among the practitioners, the machine learning practitioners. They were able to justify and so on. And then came at the parallelly, as we know, neural networks was coming up, and where people wanted to represent human's brain, right? They wanted to represent human brain as a system. So they had neurons, everything, and they were developing the system. And then they wanted to make it bigger, right? And they observed that when the neural network became bigger, it was able to do better. So they were adding so many layers and so on. And when the computational power also improved, right? As we know, NVIDIA is a major person or major industry which is a reason, which is one of the reason for this biggest revolution. Their GPU has helped us to do things in parallel, which has led to this development. Deep learning algorithms got evolved, and based on this deep learning algorithms, first they were doing it for structured data, like when there are going to be multiple columns of data, right? Then they were developing some system to do then. Like images, they were trying to do for unstructured data. We know CNN got evolved and so on. And then they wanted to do for sequence data. When they wanted to do for sequence data, they came up with architecture like RNN, LSTM, and so on, right? Sequence data, basically, there is some connection between the words. For example, if you consider text is a sequence data. There is a connection. When I'm speaking, you know that multiple words are used, but I have to put it in proper order. Then only I will be able to get the meaning. If the order is shuffled, then we lose the meaning, right? So for processing sequence data, there were multiple structures that came up like RNN, LSTM, and so on, right? And when this was going on, there was a drawback that in RNN and LSTM architecture, LSTM is just a variation of RNN. So in those architectures, we cannot give the data in parallel. The biggest revolution that happened itself is NVIDIA's GPU cards were used for parallelizing the computation. So when we give lot of data and when we work parallelly, we are able to get a very good system. That's the basic idea of deep neural network. But when we are going to process sequential data, it's not possible because the order of the data is very important. So they were giving one by one, that sequence order they were preserving. And in that situation, it was not possible to get a very good system. And at that time only, Google identified. And one of the important concept in RNN is the attention. How much of importance each word. When basically it's going to, we can use for sequence to sequence generation. RNN can also be used, right? So when we are in the nth word, we should know how to generate nth word. Means it should know what importance should be given to all the words whichever has come before. That is for example, from index 1 to n. That should be known. Then only the nth word can be generated. That is the attention. How much of importance has to be given for the words whichever has come before. And the sequence were also preserved, right? But transformer model, right? First transformer model was developed by Google, in which they did a basically translation task. They translated from English to French and English to German, and they were coming up with the architecture in which they mentioned that attention is all you need, right? Attention is more important, and we can bring the sequence in a modified way. It's not that we are not having the sequence, still we have the sequence, but it is going to be like encoding. Basically, we do embedding, encoding, and so on. So the data, that is the textual data, will be embedded. Textual embedding, that's a very broad topic which we might have discussed earlier. And next is encoding, right? So when we say encoding, positional encoding, that is very important, right? Or we can call that as positional embedding also, in which we used to use sine waves, cos waves, cosine waves to represent the order of the text, right? So transformer models were coming up, which made a variation in which they were embedding the position of the text by using positional embedding, and combining the textual embedding and the positional embedding, the data was fed into the encoders. Basically, first they had encoders as well as decoders. Now we are seeing models that in which only decoders are available. Basically, GPT, when we look at it, it is having only decoders, right? And there are few models which use only encoders also. So this revolution has brought a lot of changes, right? Based on transformer models, large language models started evolving. And we know that everyone, day to day life, people have started using large language models, Chat GPT, Llama, right? Those models have become very popular. Now, the important question is, how does it work, right? How does,
Madam,
yes, ma'am?
the slides are not changing at all.
I'm just in the first only. I will
Okay, okay,
move the
sure.
slides. Yeah,
So,
yeah.
so sorry to interrupt.
No problem, no problem. So the important question is, how does these systems work? When I felt the importance is, I went for a talk at CMZ Vellore. That was on deep learning, how deep learning techniques are very helpful for medical domain. There in CMC, they have got the IT division in which even doctors, I was very surprised to see that doctors were talking about convolutional 2D. They told that they're using convolutional 3D, that is convolutional 3D networks for their research. They have got a IT division in which they are having a lot of people working on the images, because we know that medical data, lot of images.
மேம் மேம்
Yes.
ஸ்லைடு மூவ் பண்றீங்களா மேம் இல்ல ஃபர்ஸ்ட் ஸ்லைட்ல தான் வச்சிருக்கீங்களா
மேம்
மேம்
ஃபர்ஸ்ட் ஸ்லைட்ல தான் மேம் வச்சிருக்கேன். ஐ வில் மூவ் இட். ஐ வில் மூவ் இட்
இல்ல
மேம்.
பார்ட்டிசிபென்ட் போட்டிருந்தாங்க. ஓகே
Okay,
ஓகே
okay, 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 ma'am. Because I'm just going to tell what is explainable AI in the first. So I'm telling just how it is important. Hmm? Okay. So when I went to CMZ and when we were talking actually, at the break, I had interactions with the doctors. They told that they are not very confident to use deep learning system as they are using machine learning system. They are convinced to use machine learning system, but many doctors are not convinced to use deep learning system. The reason they told it, it's a black box. Everywhere we ask, isn't it? If you have got a deep learning system, if you want to know how does it work, we are not able to tell. Why does it work? How does it work, right? So that is the reason why people have then started. Say when you have to integrate into your system, right? In sensitive fields like healthcare, education, it's very important to know how does it work and so on, right? That is what is explainable AI is addressing, and also few ethical considerations out there. So we can tell that in short, we are going to transform from the black box to a glass box using explainable AI. So now when we look at what is explainable AI, it is a set of processes and method that will make AI systems to be transparent, understandable, and interpretable by human. We will understand why this result has come, right? Why this answer has come. That we can understand once we are going to use explainable AI. So in short, they refer as XAI. So XAI's aim is to bridge the gap between the black box models like deep learning models, ensemble models, and a human interpretability. How I can understand, how does it work, right? That's what is explainable AI. And when we look at this, we can just imagine the structure like this. Today, we have got training data, which is fed into machine learning processes, which learns some function, right? Basically, when we look at the training data, there is some function, right? How the input and output are related. there is a complex function that is connecting the input and the output. That is what is being learned by the machine learning process or the deep learning process, right? When we feed the data, the machine learning process is getting applied and it learns a function which will give a decision or recommendation to the user, right? And in a normal system, the user will not know how it happens, right? Why it happens. That's the problem, right? He may have to answer sometimes why it happens, because we are going to apply in real-time systems. Means I will show you a few examples, right? In which they have developed AI systems, which has been very useful practically, right? Sometimes we have to give out reason why. For example, they have applied it for banking sectors to process loans, right? A lot of people apply for loan. Now the bank has to make a decision whether they can grant the loan or shouldn't grant the loan, right? Apart from the CIBIL score, there will be so many factors like what has happened in the past, right? Whether they have, how many loans they have got, what is their income, and so on, right? So many factors would be there. So we can develop a machine learning by deep learning algorithm to answer or to help us assist the human in making decisions, right? So suppose if it tells that a person has to get loan and another person we cannot give a loan, then we need the reason why it is making such a decision, right? That is very important because we may have to explain someone, either the higher authority or sometimes the person who applied itself, we may have to tell, right? And if it is correctable, if the reason is something, if something is missing, right? Or if it is a simple factor, then we can consider and make a decision. So always that explanation is required. So in that case, we can have a XCI module, right? Where the training data will be given to a new machine learning process, which will be having a explainable model, and there will be explainable interface where the explanation will be given to the user and he can make justifications, right? And when we tell just user, or we can tell like stakeholders, multiple stakeholders are there when we are going to have a AI system, right? Data scientists or developers are there, domain experts are there, managers or business owners, right? They are the people who invest money in that, and domain experts are the humans which are working really on the system, right? Using their experience. And whenever we are developing the AI system, we have to collect the experience of the domain expert and do, right? And data scientists generally, they look at the data, interact with the domain expert, they create the data and develop the system, right? So when the input data is given, the ML model makes prediction, and this XAI method is going to give you the explanation, and the stakeholders get convinced, right? By that, or if they want to make some changes, they will make changes. So now let's see what are the key characteristics of explainable AI. First one is transparency, right? So reveals how the AI model processes the input to generate prediction or decision. How the AI model works basically, that we will understand. Interpretability, so we will know, explains AI output in a way humans can comprehend. How I can interpret the output, right? That is very important. So it will give more details how it can be understood, right? And accountability. So it provides mechanisms to verify and trust the AI models, right? There will be mechanisms, right? To verify whether the answer given by the AI model is correct or not, right? And user-focused explanations also. We can have tailor explanation to the, because we saw there are different stakeholders, right? So each stakeholder may have different kind of interpretation that can be provided by this explainable AI, right? That's what developers, end users, regulators, owners, for each of the person we can do it. So I will try to put it in a better form by taking an example of, now we are working on education sector, right? Now, what is the main thing is, we need to have a big change in paradigm. How do we teach, right? The conventional model, what we were using till now, may not be very helpful. We have to understand how AI can support us in our teaching learning process. That is very important, right? And in that, one of the aspect is how to evaluate descriptive questions, right? This is very challenging. And we know that nowadays, a lot of online mode teaching is also happening. And in a normal environment also, evaluating the answer script, it's little boresome, right? And always there is a human bias when we do evaluation, right? So we can develop AI system. It's not very difficult, but now there are a lot of LLMs have come, lot of techniques have come. So once we understand and explore those systems, it is possible to develop a AI system that will assist us in evaluation. Okay, now let us assume that we are giving an answer script and it is giving a score for that particular answer. Maybe we have to feed some input to that, right? And also we can use various techniques like RAG technique or fine-tuning technique to impart the knowledge to the LLM. Now, the teacher can enter the key and the answers, whichever is returned, can be converted, handwritten transcripts can be converted to digital data. Lot of models have come, like when that is very good in OCR, right? So it can convert the handwritten script to digital text, which will be fed to the AI system, right? Now, the AI system tells, suppose if you tell score between 1 to 6, if it is a 6-mark question, then you give instructions for evaluating like 1 to 6, right? For example, it gives a score of 4. Then definitely we need some explanation because students will come and ask us, why I have been reduced 1.5 marks, right? So we have to, as a teacher also, we have to know what is lagging in the answer scripts, right? Then only we will be able to understand, right? So that accountability is very important, right? So when we are going to develop a XAI system, right? Explainable AI system, it's very important, right? We have to trust it. When a score is given, we have to trust the system, and then only we can adopt it, right? Then only we'll be able to take it. Otherwise, always we'll be having a fear of using it, whether this will be accepted by the users, right? Users in the sense, if I am a teacher, if I want to use a AI system that is doing automatic evaluation, I have to trust it that it will give correct score, right? Then only I can make my students to convince, right? That is very important. That we can get when we are going to use XAI, right? That's very important and it is very critical, right? In some systems, it may be light, right? We can use AI systems in which it is not so sensitive. But in cases like healthcare, right, where some treatment or diagnosis itself is going to be placed on AI system, it's very important. And finance, when I have to use a system, right? For example, I want to know how I can do investments, right? I want to know how I can tell the background of myself, my salary, my expenditures, my loans, and I can ask the finance system how I can do my investments in the future so that I will get maximum benefit, right? In that case, I should have a trust in the system. It is very critical, right? That's all. So as we saw, accountability and regulation is also very important. There are many AI regulations is also happening, right? Like GDPR, there are multiple people, so many people are talking about this, right? You might have read in news articles that even US is trying to regulate things, right? What data is being used for developing the system. When we are developing the AI system, it's very important that data is a very important component when we are going to develop the AI system. And how do we use it? So lot of AI regulations is also happening, right? Even for education, how to use it. In the Indian context also, a separate team has been formed to structure these regulations, right? How we are going to use AI in the future. So this explainable AI will help us to do these AI regulation and so on, right? And also for debugging and improvement. That's what. So why this answer is being given by the system? That will make us to understand the behavior of the model, right? So we can understand whether there is bias or errors or unintended patterns, right? Sometimes there may be some data which is leading to some unintended pattern. So we may have to remove those data. So that is one side. It will help the users to understand why the answers are coming like this. That will help the user also to improve in a way. Similarly, while developing the AI system, we can take the reason, right? Reason, and we can debug and improve the AI system as a whole. That is also possible. So always this bias, you might have heard everywhere, this bias and fairness issues, right? This is happening because of the data through which we train the AI system. when we look at LLMs, they are being trained by the data that is available in the internet, right? What happens is in internet, many people talk and their own opinions are there. For example, black, white, that discrimination, lot of people talk not good about black people, right? Based on the race, racism is so much. And based on the country also, there is a lot of bias. Based on gender, a lot of bias, right? When we are developing the system, we should make sure that this does not happen, right? So we have to find out that whether there is some unfair decision, right? It is very important to understand, and we have to remove it. So this bias identification, when we are doing the AI system, developing the AI system itself, we have to identify. There should be some kind of internal testing that we have to do, right? So I can give you an example. Amazon, few years back, they were trying to bring a AI system for their recruitment process, right? Because so many applications come and they want to find out who is the best candidate, and they felt that it's difficult for human to look at all the resumes and identify. So they were developing system, right? A system, automatic system, which will be able to identify the best resume for the given job profile. Once they decide the job profile, they will see the job profile into the system and a set of resumes which they have received for the job profile, and that system should be able to shortlist the potential candidates who have got good knowledge, right? When they were doing this, what happened was Amazon found that when they were doing internal testing, the system was not gender neutral, right? That they were having like male dominated. So for it was giving more preference to male than female, right? So engineers noticed that the system's preference for male dominated language and expressions, right? So this they identified and they were trying to rectify, right? So they were trying finding out that there was a pattern of discrimination, and resumes with explicitly female-oriented language were ranked lower, right? Females were ranked lower, even though they were good, they were having the skill set, they were ranked lower when you compare to male candidates, right? The system favored male-oriented terms and experiences, and if they are even irrelevant to job, it was recommending to the job because they are male candidates, right? So then they were trying to fix the bias, right? Why this biases? That's what one of the important thing is when we are doing explainable AI, we will also understand why the system is working like this, and we can try to fix the system, fix whatever issues there, and we can get better results, right? The system can do better. So attempts to fix the bias, they were trying to do it. Engineers tries to make the algorithm better, and then they adjust the weight. We know the different kinds of initialization, because initializing the weight is very important when we are going to develop deep learning algorithms. Initializing the weight is very important. So they were trying to adjust the weight assignments and so on, but that didn't work out. And then they found that actually the reason for that behavior is their data itself was biased, right? When they developed the system, they might have definitely given some data based on the past experience, right? And maybe that in the earlier days, there were not many female candidates who were applying for the job. So they had many male candidates who were applying for the job. So they were shortlisting males, right? That was the data. So they found that the data itself is biased, and the model's complexity made it difficult to eliminate the bias, right? So at one point of time, they thought that it's very difficult to work with this data, and they discontinued the tool itself, right? In 2017, Amazon ultimately abandoned the tool, right? They concluded that it's not going to guarantee fair outcome, so they stopped using it. Maybe now they're trying to build another one also. I'm not sure, right? So company is going to, now they were doing like more traditional hiring methods, right? So when we look at the benefits of explaining AI, right, or why we should do, or what is the benefit, it will reduce the cost of mistakes, right? Human is error. We do mistakes, right? So we can try to reduce it. Of course, it cannot be zero, but when we have a AI system to assist a proper AI system, we can try to reduce. And when we are going to have AI system also, we should make sure that it works correctly. For that, if you use explainable AI, then we are trying to minimize the mistakes made by the AI system also, right? So it will reduce the cost of mistakes and also reduce the impact on model biasing, right? And errors can be minimized, and code confidence and compliances can be improved, right? Model performance can be improved, and informed decision making. Okay, we can have good decision making when we are going to have this explainable AI. So, if you want to develop the recruitment AI system, for example, then there should be diverse training data, right? So, should have a data set that represent diverse groups to avoid skewed learning. Otherwise, as we had in Amazon, that bias will happen. Bias direction and auditing can be done. Right? Regularly, we have to audit the AI system for bias using fairness metrics. So there should be transparency and explainability when we are going to use these XAI techniques, right? Understand and explain why the candidates are ranked higher or lower. We have to have diverse stakeholders also. When we are going to develop a system, there should be diverse stakeholders also. Women should be there, minorities should be there. Then only they'll be checking the aspects. This is a very good point that we may have to discuss. We all know that ChatGPT was developed, right? When ChatGPT was developed, it's not only the deep learning algorithm, they have got RLHF, that is reinforcement learning with human feedback. That is also one of the important technique by which they have improved the performance. Google was not very successful. Actually, the breakthrough happened from Google only. They only developed the transformer model, right? And but they were looking in one aspect, that is just improving the performance of the deep learning model. I'm just telling transform model is also deep learning model because there also we have got encoders, decoders, structure only, right? It's a specific deep learning model. And they were working on improving the overall deep learning model only. But OpenAI, what they did was they combined this reinforcement learning also. They did RLHF also, that is reinforcement learning based on human feedback. So they were, what they were doing was, they know that definitely the data in the internet is biased, right? So they were having different people. We can see that in internet, they have got people at different locations, right? Like people, minority peoples, they were hired by OpenAI and they were given the job to test the system, what they initially developed, right? And check if there is a bias. They should ask questions about themselves and check whether something is wrong when the response comes, right? Similarly, when we are going to build a model, it's very important that we have to have diverse stakeholders. Women should be there and minorities should be there in the design as well as in the testing phase. And we should also have collaboration with the human, right? We cannot just have a system which will replace, but instead we should also include. That's what the success of OpenAI also, right? I mentioned just about RLHF, right? So also the system that should have ethical and social responsibility. So we should check whether it is fair and so on, right? This AI system already we discussed. Yeah. So actually it was evaluating from 1 to 5 and so on. The system what they developed was trained on the 10 years past data of Amazon, right? And historical, that's what we discussed. Historical data were basically more male were there, male dominated tech environment, that's what. So automatically the system learned the bias, right? It learned the patterns from the training data and it just used the keyword, right? For successful candidates as male candidates. It thought that a male will be more successful, right? And because more successful resumes were there and women were thinking as downgraded people by the system, right? And also when we look at real world applications, many important sectors like healthcare, education, law, automated system, this decision can be having a life altering consequences, right? So it's very, very important when we apply in these sectors, right? We might have heard that now AI systems are being developed for law, right? Because there are so many constitutions, there are so many rules like law that has to be memorized by lawyers, right? It will be helpful if there is a AI system that assists the lawyer. So it's very important that the system which is developed is correctly going to help the lawyer. It should also reason out why. According to this section, right? It should quote and tell. By this only, I am able to infer this. That is very important, right? So it should be able to tell how it can give a conclusion but it should be able to tell what are the different aspects that it has seen from the learning data and give. Because as we all know, hallucination is a very serious issue of LLMs, right? Why hallucination happens is because they are generative models. Basically, they have been trained to generate word by word, right? We will give a text, and based on the text, it is going to generate the next word and so on, right? It's a generative model. So even though it has not seen anything in the training data, since it is generative model, based on the text alone, it is trying to, using the words, it is going to calculate what is the probability of the next word, which word has the highest probability that shall be generated, right? That is the problem. And when we look at these domains, right, these domains are very sensitive domains, which will help to make important decision in people's life. So those decision has to be correct, and otherwise something like life altering consequences can happen, right? So healthcare, when we look at it, it can be used for diagnosing a patient, right, with a particular disease. It can be helpful to diagnose, and also it can help doctors to understand, validates the model reasoning. And finance, yeah, as we discussed, it is very popular that banking sectors are now working on AI systems. So whenever a loan application is being processed, right, it will be helpful if they have a AI system that will assist them, right? So it can approve or deny, but the justification is very important. And also there should be a transparency in the credit scoring system. Then only the end user also will be very happy, right? How he is getting that. And in education, right? In education also, now we might have seen many apps like Khan Academy and the Duolingo. Those apps have now started having very personalized recommendations, right? When, for example, if like five of us are doing the same course, right, in these platforms, we can see that based on our performance, right? How do I answer, uh, or how do I interact with the assessments, everything? Or it will find out what is the strength and weakness of me, and based on that, it is going to give the personalized learning recommendations, right? These systems have become very helpful. So you have to tell it. We should be able to identify why such recommendations go, right? That is very important. That's what is here, right? And autonomous vehicles. There are self-driving cars, of course, not in India. We have seen videos, right? In abroad, autonomous vehicles are very popular. So there it is making decisions. Now I have to brake, or now I can increase the speed. It's very important that self-driving cars should do the correct thing, right? Because it's a potentially life-threatening issues. If it's going to make a mistake, then it's going to be very difficult, right? So the key concepts, or that is, what are the fundamental things that should be done, or how it can be done. There are multiple ways that can be done. First one is intrinsic. How can we develop an explainable AI system now, right? We can do it either intrinsic or post hoc explainability. Intrinsic means we are going to make this explainable AI models to be part of the system what we develop, right? When we are going to develop a system, for example, if you're going to develop a system for approving or denying a loan, right, in a banking sector. Okay. So when we are developing that system itself, if you have a module which will find out the reason, okay, during the training itself or internal testing itself, we are going to have a module, right? That module itself will be checking whether the answers are correct, or why those answers are being given. Then it's going to be intrinsic. Post hoc explainability means it will be a separate module, which will be a separate module from the system for which we are giving explanation, right? So the system for which we are giving, for the original AI system will work separately, and based on the decision, we give the input. For this input, this output has come. That way we'll give it to the explainable AI system, right? Then it will try to interpret. For that, we have to train. That's what we saw that block diagram. We have to train the explainable AI system also with the data with which we have trained the original system, which is making the decision. Okay. Then only this system will be able to understand why this decision, based on the training data only, this decision has been made. That will be understood. That's one. So we can say that intrinsic explainability means models inherently. That's what it is going to be inbuilt. okay, inherently designed to be interpretable, such as you can have like linear regression, decision tree, rule-based systems can be there. Post hoc explainability means you are explaining the behavior of complex black box model, right? You are going to be a separate system after training using external, right? So it's not going to be part of the building process itself. It's going to be something separate, which will be using some methods like visualization or approximation methods, and it can find out why this answer is coming, right? And also, we can have two types of explainability, global explainability and local explainability, right? So global explainability means understanding why this overall decision has been made, right? Or why this overall decision has been made for the logic of the model. Local means why the model made specific prediction for every input, right? Global means how does the entire system or why does the entire system work or how does it work, right? That's what is global explanation for any data, independent of the data. We just understand the model whichever we have developed, the AI system whichever we have developed, we understand how does it work, right? That's what is global explainability. Local explainability means for a particular input, we try to understand why this prediction has happened, right? That's what is local explainability. And then there are two methods when we are developing a explainable AI system, model agnostic and model specific, right? So from the name itself, you can understand model agnostic means it is applicable. This technique is applicable to any machine learning model like Lime, Sharp. These are example tools that I will give an idea in the forthcoming slides, right? So model agnostic methods means they are applicable to any machine learning model, but model specific means it is for a specific architecture, for a specific model architecture, we are doing it, right? Feature example is feature importance and decision trees, GradCam for neural networks, and so on. And there are two ways to do. The explainable AI can be done in two ways. One is interpretation, another one is explaining, right? So interpretability means you're going to just look at the answer, right? How human can understand the response, right? How easily a human can understand the model's operation. That's what is interpretation. Explainable means you will have methods and tools that helps human understand complex models, right? Explanation for deep learning outputs. And when we look the common techniques that are there in XAI, now we saw model agnostic techniques. Lime means local interpretable model agnostic explanations. So here it will focus on explaining individual predictions, right? Because it is local. From the name itself, we can understand. We already discussed there will be global models that we can develop as well as local models we can develop. So when we tell local interpretable means for a specific prediction, we are going to check, right? And the method, it will create a local interpretable approximations, like, so example, linear regression can be used for a specific instance and we can find out what is happening, right? That's what the example is. You can check why a loan application was approved for a specific customer, right? And why it is getting rejected for someone else. Sharp is actually, it's a technique, shapely additive explanations, right? So it focuses on contribution scores, right? So we know that there are multiple features, right? When we are giving the data itself, there are multiple features and the AI system is going to consider these features. It's going to give some weights and then make the decision. Maybe some features are given more importance, right? And some features are not given the importance for making the decision. So in this shapely additive explanation, the focus will be to assign contribution scores, right? How much contribution is made by each of the feature, right? That they will try to find out, and they are using the concepts of little game theory to make this understanding, right? So the method will be like how each feature impact, right, the prediction by simulating. They will, because it's based on game theory, we know that in game theory there is a lot of simulation. They simulate what if scenarios, right? See, to understand how a system works, what do? They try to enumerate, right? I can just compare this to what we generally do when we code problems or even when we develop some systems, right? For example, we are developing a web application and let us assume that it's going to interact with the user and it is going to give some response, right? Testing is very, very important in every system development. So when we test, what do? We give different possible inputs, isn't it? And we find out what happens, whether the system becomes respond correctly, right? For example, if the input is number 5 or something, right? And it has to navigate to page 1, then we give 5 and check whether it is navigating to page 1. If the input has to be 10, right? If it has to navigate to page 2, then we give the input as 10 and we check whether the page navigates to page 2, right? And if it is 15, it should go to page, something like that. So if there is some error, like obviously if 500 comes, then we understand that for this particular scenario, it is not working correctly, right? So similarly, what we can do is we just try to simulate this, right? We are simulating the different data for that particular scenario, and then we check what is the response and we identify the most influential factors, right? Example, maybe like predicting house prices, a very popular example that Andrew Ng start his course, right? So we can find out what is the most influential factors that we can understand. This is one of the techniques. And the next technique is partial dependence plots. We can do some plotting. We can use even heat maps for identifying why the system behaves like that, right? So here partial dependence plots means they show the relationship between the feature and the target variable, right? Something similar to heat map only. How much influence is being made by the feature for the target variable, for the output variable, that we focus and we visualize how feature impacts the prediction while holding the some feature constant, right? And another one is counterfactual explanations, right? So we just here, what do is we assign some actionable insights, right? By explaining what if scenario, the same thing. We create some scenarios and we are going to create some counterfactual explanation. That is, for example, you will give a scenario like this. Your loan have been approved if your credit score was 50 points higher. Like this, we give a scenario and we check, right, whether that is correct or not. By that technique also, we can identify or find the explanation of the system, why the system behaves like this, right? And feature important analysis can be done. So we can rank the features by their contributions to predictions. We can identify which factor is most influenced, right? For example, if you're going to do a student performance in an AA grading system, then we have to find out which factor is important for that particular student, why he is getting good things. And then apart from this, we have got gradient-based methods. That's what is GradCam is. Here we try to explain the decisions made by the deep learning models, right? So we highlight the important regions in the input data. For example, if we are doing for image, right, we can tell these are the important region that has influenced the decision made by the deep learning system, right? We can have like that. We will be able to explain why the neural network classify the images because these pixels were used for the decision. That we will be able to understand when we use gradient-based methods. And there are tree-based methods. So tree-based methods means feature importance in the decision trees, right? So when we are having decision trees, when we are developing decision trees, features are going to be collected automatically and they do some feature ranking and also rules are there for decision making, right? So this tree-based method can be used to find out what is the impact or why this particular decision has been made. So it extracts the insights from the tree-based models as something like random forest, XGBoost, and so on. So we will have a clear idea about the classification task, why this particular data is falling under this class, right? The decision path will be clearly shown when we are going to use those models, right? And we can have rule extractions, right? Decision rules can be used. So we extract human readable rules from the models, right? We can do a conversion of decision tree into if-then rules. That also we can do and we can find out. As we discussed, heat maps can also be used for visualization, right? Heat maps, how actually they will also tell what is the impact, right? We find out the score, right? We find out a score from 1 to -1. We can tell whether this is going to be a positive dependency or a negative dependency, right? When then there is positive dependency, then the maximum value will be 1. If the particular feature is very important, right, it is going to positively influence. For example, if you are developing a system for identifying the price of the car, right, reselling the car, okay. So in that case, what we can tell is, what can be the positive factors? Positive factor can be like something like the brand of the car, right? Because there are few brands, but that doesn't directly influence, or else we can tell like what is the original price of the car, right? If the original price of the car is high, then the resale price also will be high, right? So that is going to be a positive correlation. Basically, we compute the correlation between the features and the target variable, right? But if you're having negative impact, for example, the number of years before it was purchased, right? That is an important factor. As the number of years increases, what happens is the price decreases, the target variable decreases. So it is a negative correlation thing, right? So that can be identified. So heat maps basically does visualization of the most important features, right? Saliency map in image data, I can tell like that. So there are decision boundaries that show how a model divides the feature space. You can construct a decision boundary using these things, and we can identify which feature space is having more classification data, right? And we can also generate some text explanations, right? Generate some natural language explanations for predictions. GPT-based explainers can be done. So this is just a outline. This figure shows us what are the best practices that we can have when we want to develop a explainable AI system, right? When we want to develop a explainable AI system, what are the things that we can do? What are the different ways we can do, right? These are the different ways how we can develop the system. First one is feature importance, right? You can identify the importance of the features and you can try to correlate the features and the target variables, right? We saw that even graphical methods can be done and so on, right? And you can do model agnostic methods or model specific methods. When you tell model agnostic methods, they are like general, right? They are general strategies irrespective of the model. When we tell model specific method, here it will be specific. In model agnostic methods, we can have, that is the system itself will be an individual entity. It is not related to the entity or the model which is being used for making the inferences, right? Rather, this model agnostic methods will be an independent entity where it will be trying to do something like some techniques, some statistical techniques or some interpretation techniques will be used, right? Counterfactual, here, what if, right? We generate the scenarios, we ask some questions and find out how the model is going to respond, right? By that way, we understand how the model works, right? This is something similar to we try to understand a person in an interview, right? How much of knowledge he has means we can give some we can ask for some reasons, right? We ask some questions and find out the reason. The same thing. And also visualization techniques, as we discussed, like heat maps or other plots, right? We can do those plots and understand what is the influence of the features and so on. And lot of tools and libraries have come to do explainable AI, right? So we will quickly discuss some tools and libraries which are available and what is the purpose for which they have been developed, right? So Python libraries, when you consider, there are some general purpose libraries, right? So general purpose libraries, we have got line, local interpretable, model agnostic explanations. This is a tool which will explain individual predictions, right? By approximating the black box, right? For every input. That's what locally with a simpler and interpretable model. When we look at the features, it will work with tabular, image, and text data. And it is model agnostic, right? It's independent of the model. Okay. So the usage will be to explain why a specific prediction was made, right? Sharp is shapely additive explanations. It provides consistent and accurate feature importance score, right? And it is going to be based on the value from cooperative game theory. So here it will be generating different scenarios. Okay. So it can also handle tabular image and text data and visualizations like summary plots, force plots, dependence plots, and so on. And it understands the global as well as local impact of the features on the predictions. It can be used for global case like generally why the model works like that, okay? And also local for a specific input, why the model works like that. So for both the cases, this will be useful. The SHAP will be useful. This Python library will be useful, right? And ELI, explain like IM5. This is a very interesting thing. You can also, you might have tried already. Otherwise, you can also try. Suppose if you want to ask something, some interesting questions, right? And you want to understand in a better way, then what you can do is you can ask even the AI models like ChatGPT or Llama model. If you happen to work with that, then you can ask a concept, right? For example, you can ask a concept like how does the LLM work, right? And you can explain like I'm five, right? When we ask it, then it will give a question. It will give an answer, very interesting answer, right? We can also try that. I'll just show you. What is hallucination? So it is giving an answer. I asked, I am a 5-year-old. Explain like I am 5-year-old. This is a very popular thing to understand how a system works, right? So what is hallucination? I ask, okay, imagine you have a big box of crayons and someone asks you, do you have a magical rainbow crayon that can draw by itself? Now you don't really have magical rainbow crayon, but you get excited, so excited, you say, yes, I do, and start describing how cool it is. That pretend story about crayon is like a hallucination, right? For a computer or AI, it is when a computer says something that sounds real true, but actually made it by mistake, right? Just like a magical crayon story, right? So you are asking like 5-year-old, like we can many things. I just tried out what came into my mind. But generally, we can ask even complex concepts, it will try to explain. This we have tried when we were developing some systems using based on drag, right? To have a better understanding about how the system is working, right? So we can use this. This is a popular package, explain like I'm fine. We can use this to understand how the machine learning happens and how the interpretation is happening, right? So the we are going to use machine learning predictions in a simple and an interpretable manner. So when we look at the features, it is model specific and model agnostic, right? Sometimes it will be, we can develop a system which is specific and sometimes it can be general model. And it supports scikit-learn, that is the library for machine learning, and XGBoot and LightGBM and more. And it will be helping us to debug and interpret the model during development and make the model better. Next, we have got interpret ML. This is another one Python package. This is a package developed by Microsoft, right? For model interpretability. How does it work for that? So it offers both glass box interpretable and black box explainability, right? Glass box means we ourselves can see what is inside, but we have to interpret, right? This is inside the box and so on. So they call that when there is interpretation, it is like we are able to see it and we are trying to understand it, right? We are going to make some interpretations. Whereas if it is black box, we will not know, right? What is inside, and someone has to explain it, right? That's what explainability methods are there, as well as the glass box interpretability methods are there. It integrates with Sharp and Lime that we just discussed before, right? These two libraries already we have discussed. This interpret ML integrate with those packages also, and it can compare explainability of different models that can also happen. And then we have got deep learning specific tools, right? Actually, these tools are available for machine learning techniques also. In practice. What we can understand is machine learning models are based on some mathematics, right? Some mathematical concept is there. And based on that mathematical concepts only, it is going to make interpretation on the data and come up with a function, right? Come up with a function. And then we use that for our purpose, whatever AI system, right? But when we, so there is some sense that we can make out based on the mathematical concept and so on. But in the case of deep learning, actually it is more hidden, right? We cannot easily understand how the system interpret the data, why it is giving the output and so on, right? So it's very important that we should use specific tools, deep learning tools when we are developing the systems, right? So first one is CAPTAM. CAPTAM is a deep learning specific tool, which is being done for PyTorch library. As we all know, PyTorch is a very popular framework, which is used for developing deep learning systems, right? So this CAPTAM is going to be used with PyTorch library for model interpretability in deep learning. And when we look at the features, it integrates gradients, saliency map, layer con. These are visualization techniques, right? Gradients, we know, just now we discussed. Saliency maps means they are all like pictorial representations, right? That will help us to understand. Specifically, it is designed for PyTorch models, right? And we can use it for making predictions in computer visions or in NLP models. And next one is GradCam, gradient weighted class activation mapping, right? So it visualizes the important region. As we discussed, it is going to identify when we are, for example, if you're going to use it for checking why the system is answering this as a cat. If you have got a object detection system and you're giving an image to the system and the image is able to tell this is a cat, right? Then we have to know why, on what basis it is telling. So this particular GradCam will be able to tell the pixels. Okay, we can identify the pixels which is dominated for the decision, right? So we can use this for understanding and interpreting, right? So it is applicable to, as we all know, convolution neural networks is the one which is helping us to work with images and vision, right? So we can use, that is, it is applicable to CNNs. And when we look at it, its usages, it's in the area of image that influenced classification decisions, right? And there are multiple visualization libraries. As we know, visualization is going to help us to make better understanding about how the system is working, why the system is making such decisions, right? Based on the features, we can have some plots and so on. So when we look at the libraries that are present in Python, Yellowbrick is a popular library, right? It is going to be working with scikit-learn library, right? As we know, scikit-learn is the library which is used for machine learning. This Yellowbrick will work along with the scikit-learn and will identify, right? There are like tools for feature importance and residual analysis. And we can visualize and interpret model behavior using this. And we have got WhatIf tool, right? So WhatIf tool is a Google developed tool integrated with TensorFlow. TensorFlow is the library, very much similar to PyTorch. And when we are going to do a lot of research, right? If you want to know why a system works like this, right? When we are developing a deep learning system, definitely we have to go for PyTorch, right? PyTorch is by Meta. Originally, when it was Facebook, they developed the library PyTorch, and it will be helpful for dissecting, right? When you are developing a deep learning system, we can dissect and see how does it work, right? For that, we have to go for PyTorch. But whereas TensorFlow is the one which was developed by Google, and the purpose of this is it will be helping us to do easy integration with the system. For example, if I'm developing a web application for which I want a AI system, right? And I want to integrate both of them, then we can go for this, right? So anyway, why the system answers like this? If you want to just know, then definitely you have to go for some tools, right? So this WhatIf tool will help us to know, right? Why the AI system developed using TensorFlow works like this, right? So we will have different scenarios. This enables testing using different scenarios for different inputs. So it will explore what is the fairness of the decision, what feature is impacting this, and so on. And there is another one tool, that is TensorFlow Explain. This is another one framework specific tool, which gives the explanation, right? Interpretability, like integrated gradients and GradGAM for TensorFlow models. And it is used for deep learning models in TensorFlow. And we have got AI Explainability 360. This is also a very popular tool, which will help us to understand why the system works like this. So it is by IBM. IBM made this, and it's an open source toolkit for explaining AI models. And when we look at the features, it is called diverse explainability methods. It emphasizes on fairness and bias, and also it will be helping to do end-to-end explainability in the enterprise application. There is another tool specific, that is framework specific, H2O.ai. This will help us to do explanation AI, that is explanation system, that is with machine learning platforms, right? We can integrate this with machine learning platforms, and we can do, and it will be helping us to develop model agnostic things. And it is used in industrial applications which require scalable solutions. And we have got explainable boosting missions, right? This is a glass box machine learning. Glass box means interpretability will be there, right? So we can have interpretable model based on this. And when we look at the features, it is very accurate and interpretable, and it's used in healthcare and finance applications. And there are also specialized XA platforms, right? And now we know that these platforms are becoming very popular. Though we work on developing systems, right? We can write Python code when we want to do machine learning algorithms, right? There are packages like scikit-learn is there. And when you want to do deep learning, PyTorch, TensorFlow packages are there, right? And R is also there. R is another one framework which will help us to do data science and machine learning stuff. We have got different packages and different platforms, right? In which we can develop our own AI systems or data science systems. And also we have heard that many cloud platforms are available, right? Like Microsoft has got in their cloud platform, and Azure, right? Azure has got many AI tools. And also in this Amazon has also got number of AI tools. I came across like OZR, right? I was working on a project in which we had to have a handwriting regression, and that was like very cursive, and they wanted very close, like 99.99. They were not fault tolerant at all. They wanted to have a very good system, right? 100% system. When we were working on it, we saw different algorithms, different even LLM models have come. We were exploring that. Of course, the data was very complex because it was extracted from checks, right? When we did check, there is additional data that is also available, the printed text, everything. So it was very complex. When we were working on it, we just saw that Amazon has got a system, right? But that system is like a black box. You will just use it and you will pay for how many OCRs you do, right? Like that. And also I have heard that many companies, right? They use this, right? They do basically, these platforms also do something like grid computing, right? Grid computing is something like when we are going to have hyperparameters, right? Hyperparameters or something like, if you take a very simple machine learning algorithm like decision tree, right? In that, the height of the tree is a hyperparameter, which is given by the data scientist or the person who is in charge of the algorithm, right? We will give hyperparameters, but we are not very sure. We try to reason out the hyperparameter, but there may be a value which will be better, right? In grid search, what happens is the algorithm will be run for multiple iterations to find out what is the best hyperparameters that we can feed and so on, right? Like this, when we go to the cloud platforms, right? When you're going to have a cloud platform and it is going to support a AI system, support us to develop a AI system, they can run different algorithms, right? Like they can use naive Bayes for our case, they can use like decision tree, random forest, and find out which is the best thing, right? Of course, we can do it. We have to do it one by one. We have to do it. There, they have automated. So these cloud platforms have become very popular, right? and they are helping us to develop AI systems. Similarly, there are also XAI platforms, right? XAI platform means explainable AI platforms. Lucid is one of the tools which is available as a cloud platforms as a service, which will be helping us to visualize the deep learning models, right? So it can be used with TensorFlow, and it is focusing on the neural network interpretability. And we can visualize features learned by the CNNs. That can be done. Google Cloud AI explanation, right? So the purpose is to check or explain the models deployed on Google Cloud. And when we look at the features, it is for feature attribution, for prediction. What are the important features that has helped us to do the prediction? And it can be used in scalable and cloud-based treatment. Azure is also very popular, and they're providing a lot of AI services. So Azure machine learning interpretability is there. And we see it's offering explainability for models trained in Azure ML, right? And it can integrate with the techniques. We just discussed about the different techniques that can be used for explainable AI. So we can integrate with Sharp and other techniques also. And it can be used in enterprise level model deployment and explainability. So there are multiple tools available. How can we choose the tool, right? That question obviously comes, right? Even in deep learning, many people ask this question, whether I should go for PyTorch or I should go for TensorFlow. The answer is very straightforward, right? We will tell that when you have to have a AI system that should be integrated with another web application or mobile application. And if you want to deploy it, definitely you have to go for TensorFlow. TensorFlow is easy for deployment. But whereas PyTorch, when we will go for PyTorch, suppose if you want to do a research on how your system works, you have to dissect and see, and if you have to improvise, then we have to go for PyTorch, right? Of course, there are, we can combine, we can convert, exactly not conversion, but we can add layers and make the code compatible. That is possible always, right? So here also, we have discussed about different models, with different models that will help us to understand how a AI system works, right? Then which tool, which package or which tool should we go? When we see that, for general ML models, we can go for Sharp, Line, ELF5, right? For deep learning, we have got CapTime, GradGam, or TensorFlow, right? For visualization, we have got Yellowbrick and what of tools. And for industrial scale applications, when you've got very big applications, we have to go for something like AI Explainability 360 or H2O AI. So when we look at the ethical principle in AI, transparency and explainability. Transparency is very important as well as explainability is very important. So the challenge is the black box AI system often lacks interpretability. We are not able to understand how the decision was made. We understand the decision, right? But we do not understand why the system is making such a decision. So ethical means the users or the stakeholders has to understand and trust the AI decision. That is very important. As we discussed before also, when we are using for loans, it should be able to answer why it is sanctioning for someone and so on. And fairness and bias mitigation, right? So sometimes unintentionally, we can have biases in the training data, right? That's what it is similar to how a child is being brought up, right? When the children are being born, they are not having any bias, right? They are neutral to everything. But when they are being developed, they are being brought up in a society, based on the society's impact, they are having some biases, right? That's what. Similarly, the data with which we are going to train it, the models may unintentionally have a bias, right? But we should be able to identify. So the ethical importance is we should have equality in decision making, right? Even though there are diverse groups, this already we discussed. We discussed about the Amazon's recruitment system, in which we found that the data was biased, right? The data was having highly male dominated, right? So many male people were recruited in the past, and very few female candidates were recruited, right? So to avoid that, we should have proper data, right? We have to have equality. So we can identify if you're having a explainable AI system, then we'll be able to understand, right? This is the reason why the system is being answering this, right? Then based on that, we will be able to find out what is the drawback and we can avoid it, right? So we can avoid gender or racial bias in hiring algorithms. And also privacy and data protection. So AI system often rely on vast amount of personal data, right? And sometimes there is a risk that it may be misused or unauthorized. That can be avoided when we are going to have some ethics, right? So ethical importance is protects individuals' privacy and adheres to regulations. Like already we discussed, in India context also, a separate committee has been formed, right? To make sure that the system, what type of system we can develop, what data, how the data should be used. For those regulations, there are committees formed, and the government is also very much involved into making sure that we are using the right things, right? So like GDPR and India's Digital Personal Data Protection Act is there, right? So we ensure that medical AI system handles patient data. This is very important, right? We should not reveal the personal details of the patient and so on. And also, we determine who is responsible for decision made, right? Whether there is developers, organizations, and so on. And also, we should clarify the liability and ensure readers there is no harm, right? And autonomy and human oversight. AI system might make decisions without human involvement. That is potentially risk, right? Sometimes it may lead to unethical outcome. So it's important that human control is always there over critical decisions. That's very important. Even in healthcare. Healthcare, we know that it's a very critical sector, right? Where people have to get involved, human have to get involved and make the decision. And also there may be environmental impact, right? So training large AI models, as we know, will have significant computational resources, right? And contributing to carbon emissions, right? We can also verify this. That is, when they were training bigger LLMs, the carbon emitted is equivalent to the carbon emitted by cars in the entire globe for 5 years. Such a huge amount of carbon is getting emitted because a lot of systems are running, right? And there should be cooling, for proper cooling should be done for that. That leads to a lot of carbon emission. Electricity is being used, right? So there have been, why many models have become open sources. The government by itself, they themselves put a restriction, right? When you're going to train such a large amount of data, right? Then a lot of carbon emission will happen. And as a social responsibility, they have to expose the model so that others can use for their research purpose and they're not training by themselves, right? That is also very important. Environmental impact is also there, which should be done, right? And that's what we should be, in such a case, we should have to do energy efficient AI models, right? Suppose if you have a good infrastructure, rather than going from the scratch, when you want to develop your own system, rather than going from the scratch, we can take a model, right, which is already trained on a similar data for our similar data to our domain, right? We can take those models and we can try to fine tune it. By that way, we will require only less computation power. By that way, we can also be doing some good to our environment, right? And safety and security is also very important, right? We should make sure that there is no harmful outcome happening with the AI system, and there should not be misuse and ensure reliable performance, right? There is, for example, spatial, this is becoming very popular nowadays, isn't it? Misusing the AI, using the facial recognition, or they're able to picturize ourselves, right? We saw that a lot of cheating is happening nowadays. They create videos like our relatives or someone speaking, and they are threatening for some money. That is also happening, right? So this facial recognition system can also do some spoofing attacks. We should be very careful, right? So ethical challenges should be like, we should be able to discriminate proper data. There should be regular audit in the system what we develop and so on, right? And there should be surveillance, continuous surveillance should be there, and privacy should be ensured. Right. So we can see that when we are having a explainable AI system, we should be able to justify, right? Why? And we should have a control over the system. It's very important. that we understand. When we understand, then only we will have a control over the system, and we should also have expression to discover what is happening and to improve, right? These are all the different aspects in which we are going to uh, have explainable AI system, right? So frameworks and guidelines for ethical AI, principles by leading organization will be there, like EU AI Act, right? They focus on transparency, fairness, and risk management. And we have got IEEE ethics guidelines, which emphasizes transparency, accountability, and privacy. IACDA principle, they also include growth, sustainability, and trustworthiness, right? So these ethical A frameworks, as we discussed, they insist on fairness metrics. We have different fairness metrics like the demographic parity, right? It should not do anything based on the place, right? If someone is residing on a country like Pakistan or Afghanistan, it should not decide based on the location of the person. Demographic parity should not be there. And also explainability should be, adoption of XA tools should be there. And human-centric design should also be there. We should prioritize the user needs and ethical consideration when we are doing AI system, right? So this auditing, testing, everything should be properly done. And the data also should be private, kept private. Whatever we um, use for training, that should be kept private, and that we should properly maintain the diversity and the inclusive terms also. Right. So these are all the important things, and we have discussed about the tools. Now the question is, okay, we know what is explainable AI, many tools are coming up, many packages, cloud platforms, everything is there. Is it important for education and research? When we look at it, yes, it's very important, because we have to know, right? Educators and researchers have to understand the decision made by the model when we are, particularly when we are using for our own purposes, right? That's what I told. The future is like, we will have assistants, right? Assistants. They will be co-pilots traveling with us. They will definitely have, teachers will have co-pilots traveling with us, helping us in making the decisions, in grading or predicting the student's performance, understanding what is the strength of a student, what is the weakness of the student, and so on, right? So we need to have why that decision is being made, right? Trust in the AI system will make acceptance, right? Among like students, administrators, and teachers. And also we can have better decision making. We can have personalized learning, which is very important. And also it can help us to do a better curriculum design, right? For the future students. It will enable researchers to validate the hypothesis. Okay. And also find out what is the new pattern. It's very important for researchers also to focus on explainable AI. And also we can have a ethical and a fair AI practice when we are going to have XA in education and research, right? It will avoid biases in grading, admissions, and resource allocation. And also it will show diverse student demographics. So these are all few applications in a education sector, like personalized learning can be there, right? Explain why a recommendation. This already we discussed, right? It will help the educator to validate and refine the AI-driven personalized access, right? We can have automatic grading system. It can help to grade descriptive answers, essays, coding assignments, right? And we can have an explanation why grading systems, right? Why such a score is given. Allow the students to challenge under their grade and ensure fairness. And we can have predictive analytics for students' performance. We can just do some predictions, right? I saw recently a system in which they are keeping track of the practice time, right? Assessme is the name of the tool, which is a plugin for Visual Studio, right? In that, what they're doing is they are trying to keep track of the student's activity on the mission, and they are doing the predictive analytics, right? This much of score will be got by the student based on the practice, what he has made, and so on, right? So we can do some prediction. We can also give suggestions how to improve them to get better scores and so on, right? So it will explain which factors are most important for the prediction, and we can provide a guidance, right? And as we discussed, curriculum design and resource allocation, here also we will have a support from the AI, which can help the future generations to make this shift. As we know, nowadays, education has to be reformed, right? We should have a very good approach towards making a good curriculum, and how we can change the paradigm itself so that we will be able to make the students to learn, right? And model validation and interpretability is also very important. So it's important that we should have and use the tools for education. So we can use for criminal justice. So research, when we go research can be applied to healthcare and criminal justice. Law is a very important sector. And as we know, many systems are being developed for high court, Supreme Courts, and so on, right? That will help the lawyers to make decisions, right? So we should be able to discover the insights, right? What is the thing behind it, right? So in research, we can have like genomics, right? Which works on the gene data, climate modeling, economics. This explainable AI can help to have better interpretation so that we can also do some portions, right? We can also collaborate with people, and we can also do good publications when we are going to have a good system, right? And we can balance between the moral accuracy and the explainability. Suppose if it is not very correct, right? Then we can even compromise with the moral accuracy, which is going to always give a right answer, or it is having a more meaningful interpretation than a model which does better, but it is not going to do a good, it's not going to give a good interpretation, right? Because misinterpretations can lead to some biased decision, and it may lead to some problems, right? So these are the 5 key questions, right, to answer when we are going to build explainable model. First one is to whom we are doing it, right? As we discussed, there are different stakeholders, data scientists, the owner of the product, the developer, everything, for whom we are developing this explainable AI system. Based on that, we have to focus on the responses. And we should also, the second point is why explain, right? What is the objective for what, how this result will be used, that we should understand. And how to explain, right? What are the different methods? There are different methods to explain it, either using textual data or using visualization. We should be able to identify how to explain it and when to explain, right? So we have to understand when, before or during or after the model is being built, we have to tell when this explanation can be given, right? And what are the explanation techniques, right? Taxonomy of different techniques. There are various techniques by which we can do the explanations. We should also decide. So these are all the things that we have to consider when we are developing a explainable AI system, right? So yeah, that's it. This is what is about explainable AI systems and its development.
Dear participants, you are welcome to ask questions to Janavi ma'am. She is ready to address them.
Yeah, you can ask if you have any
Ask you.
queries.
Yes, ma'am. I am Pooja Soni. Hello.
Yes, ma'am.
Ma'am, I had one question that while dealing with the classification problems
Mm.
and applying explainability, so does the model of explainability or the mode of explainability depend on if we are going for binary classification or multi-class classification?
Uh, Not exactly. We will decide what classification we have to go based on the problem. Whether we have to go
No,
for,
no. I mean, my problem is identified. है ना? In one case, I am working for binary classification, say for cats and dogs.
okay,
And in the other case, I have got some medical data in which I have to put it into multiple classes.
okay.
So how to choose? Though I will be using deep learning algorithm for both.
Hmm.
So now, how to decide as to which explainability technique to use, ma'am?
Uh, are using deep learning models, then we can
Yes, ma'am.
go for deep learning specific tools are there. We just discussed. So you can just use those tools and you can find out which will suit better your problem.
And
That is,
ma'am, any references which could help me in a practical implementation of XAI? Any reference, any book or anything, any resource?
yeah. Actually, the tools, we can just have a look at it. I will share the material with the organizers. I will add in the slide itself at the end.
Ma'am, just if you could give some idea.
Yeah, there are many packages that we were discussing, isn't it? Lime and other packages also specific to deep learning. So you can, one thing is we can just look at the packages and we can understand what is the purpose.
No, ma'am,
Uh,
any book or any resource which I can
exactly.
use.
That's what book exactly. I'm not sure. Based on your case, that's what I will just check and let you know, ma'am. I'll add in the end of the slides. Anyway, slides will be shared to you.
Sure,
I will
ma'am.
add it. Yeah.
Thank you, ma'am.
Hello, madam. I have a question.
Yes, ma'am.
Good afternoon, madam.
Good afternoon, ma'am.
Madam, in explainable AI, all the supporting tools are coming as library, and I could not find any in the platform where I can integrate that tool with my existing network, so that I can understand what is going on in my network. I can give some explainable answer for every local layers as well as at the output. Is it possible, madam? Is there any link or some website where I can learn these things?
Link. Yeah, there are many courses also there. But what is your main objective? To know or you integrate with your application?
Suppose if I am having some healthcare applications, and since the network is very big, large network,
Mm.
because people usually whenever they are
Using these ones
creating some
using.
healthcare applications, they keep on adding many layers and making that model very huge,
Mm.
and they are not knowing what is happening inside every layer. At the
Mm.
end, they are giving the answer. The answer is quite okay. It is able to give 99% or 99.9% accuracy. It is able to give. But
Mm.
what I feel personally is, instead of keeping so many neurons and so many layers in everywhere without any meaning, we can go with explainable AI so that we can improve the network with a small network. We can, if it is possible to create whichever how much is required, that that much
Yeah, I understand.
layers
I
we can
understand your
create,
point.
and that much neurons we can incorporate in every layer.
Yes,
That
ma'am.
will definitely improve the performance in all the ways, in
Yeah,
giving the output, in
yeah.
training,
Yes. And
everything.
the
That is my.
complexity also will be reduced. Your point is right. So to start with, we can go with something like already cloud deployments out there, no? What we discussed like Lucid or Azure, we can go for that. Otherwise, we have to go for based on the implementation. If it is TensorFlow, then there are TensorFlow specific tools that we can use.
Uh-huh.
PyTorch means there are PyTorch specific tools, packages that we can use. We can
Oh.
explore that and we can integrate and see. But if there are some free credits, we can go for cloud platforms like Azure or Lucid. We can just check in those platforms and then come back here. I guess that will be helpful. In the cloud platforms also, there are XAI provisions available. So we can try out that.
Okay, madam. And one more thing, madam. Can we take this particular thing as a research topic
Yes,
for
yes, sure.
a new PhD
Yeah,
candidate?
yeah, sure, sure.
Because the existing ResNet, something VG16 net or some higher networks uh, can be explored so that it can be well constructed for particular applications that we can do, madam, as a research.
I'm not sure because BGG 16,
Is
that,
a small only, but if
uh,
you are going for a Google net or very large network,
yeah,
that we can prove that this big network is not required for some small healthcare applications like that we can prove, no?
yes, yes, yes. Yes, ma'am.
Then will it stand as a project, madam, as a sorry, as a PhD thesis, madam?
Yes, ma'am. Because it's a good work, isn't it? We are analyzing, it will be a good work, really, because we are analyzing the performance of the system and we are trying to find out where it is not required, right? This many layers are not required, or we can optimize on layers so that many layers can be cut down. Definitely, it will be
I
good.
mean, we can cut down, we can improve the
Yeah,
performance, we
but it
can
may be
reduce the
challenging
training
because
time, everything. Okay.
only thing is it may be challenging if the scholar is
Yeah,
so
of
much
course.
motivated because this is not so popular. Many people are not working on it. To be very
Yes,
frank,
madam. Even in this ATAL FDP itself, I have heard some people's lecture where they were telling, no, explainability is impossible. Like that, uh, they have given some suggestions. One resource person,
okay.
I'm not sure about his name also, but at that time I was a little worrying because I am very much interested in explainable AI. So that
Yeah,
really your
now
talk
it's
is
a
very
hot topic.
amazing, madam. I was
Thank
very much attracted. Thank you,
you.
madam.
Like now only it's coming up. Like last 5 years, it's not even a decade. People have started talking
Mhm.
about explainable AI. So maybe now there is some difficulty. That's what that you may not get a lot of references immediately. If you're going into explainable AI, then you you need to have in-depth learning. If you are having that patience, if the scholar is having that patience, then definitely you can do it. It's not as easy as the topics now recently what we are working with LLMs or something, because there are a lot of.
Oh, yes, madam. In these, especially with the LLM and deep learning, people what they are doing, they keep on adding some layers, and anyway they are getting the result.
Yeah,
With the result, they are publishing a paper and they are leaving as such. But we must do some remarkable changes must be done from a PhD candidate. That is my wish.
Yes, ma'am. It will be a very good work. Explainable AI is a very good work, but they should put effort, right?
More effort need to be done.
Yes, yes. So you can
Okay.
focus on either machine learning. Now we saw different tools, isn't it? So you can either focus on machine learning or deep learning, and you can focus one particular aspect. That will be easier rather than having a broad scope, right? First of all, we can have our own simple neural network rather than going for bigger things like VGG or Google Net. We can construct our own network for some simple data and try to interpret it using explainability, how it does. Then we can try to do the bigger networks. That's what I think.
Okay. Thank you, madam.
Thank you, ma'am. And we come to the end of day 6, session 11 of this faculty development program. On behalf of the Department of Computer Science and Engineering, SRM Institute of Science and Technology, Ramapuram, and the organizing team of the AICT sponsor ATAL 6-day online faculty development program on transforming industry with AI, deep learning breakthroughs and real-world application. It is my privilege to extend a heartfelt thanks to our distinguished speaker of this session 11, Dr. M. Janaki Meena, Professor, Higher Academic Grade from VIT Chennai, for delivering an insightful and thought-provoking lecture on explainable AI and ethical considerations. Dr. Janaki Meena's profound knowledge and expertise in explainable AI, coupled with her ability to bridge the gap between cutting-edge research and its ethical implications, have provided us with invaluable perspective on the responsible application of AI technologies. Her engaging presentation not only deepened our understanding of explainable AI, but also underscored the importance of ethics in shaping a trustworthy AI-driven future. We are truly grateful for the time and effort she invested in sharing her expertise with us today. Her contributions have greatly enriched this faculty development program and inspired us to explore AA innovations with responsibility and purpose. Thank you, Dr. Janaki Meenam, for your generous support and for being an integral part of this program. We sincerely hope to have a pleasure of collaborating with you in future initiatives as well. A heartfelt thanks to all the participants for their enthusiastic involvement, and I look forward to the continuous success of the faculty development program in the upcoming sessions also. Thank you, ma'am, and all the participants are requested to stay connected for the next session to be handled by Mr. M.K. Kumaresan, Cloud Architect, Conversational AI from Google India Limited, Bangalore. Thank you, ma'am. Thank you all. And
Thank
the
you.
business already joined, then all the participants are requested to be stay connected.
Thank you, ma'am. Thank you.
Thank you. Janaki Meenam, please make me as a host and leave the meeting, ma'am.
Okay, ma'am. Okay.
Yes, ma'am.
Yes, ma'am. I have made you a host.
Yeah. Okay. Okay. Thank you so much, ma'am. Central Selvi, ma'am. I think Kumaresan has
Yes,
already
he
joined.
joined, ma'am. He already joined, ma'am.
Okay. Then I will make a host.
Ah.
This is the ma'am.
Sir, good evening, sir. Kumaresan, sir, good evening, sir. Ma'am, shall I start, ma'am?
Yeah. Wait, ma'am.
Ma'am, can you hear me?
Sir, good evening, sir.
Good evening. Can you hear me?
Yes, sir. Yes, sir.
All
Yes,
right.
sir.
Thank you. Yeah.
Central, ma'am, please introduce me.
Okay, ma'am. It is an honor and privilege to introduce our esteemed resource person, Mr. M.K. Kumaresan, a distinguished cloud architect, specialization in conversational AI at Google India Private Limited, Bangalore. Mr. Kumaresan holds an impressive academic background, including a postgraduate program in artificial intelligence and machine learning from the University of Texas at Austin, an MS in software engineering from BITS Bilani, and a BE in electrical and electronics engineering from Nurul Islam College of Engineering. With over 33 certifications spanning multiple technologies, Mr. Kumaresan is a visionary leader in AI-driven digital transformation. His career has evolved across top tier technology firms, including Google, advancing AI driven conversation, Cisco, innovating in VoIP communications, Capgemini, enhancing network solutions. He is an expert in cloud computing, solution architecture, conversational AI, machine learning, networking, and unified communication. Beyond this professional excellence, he actively contributed to technology communities like Google developer groups, Women Tech Makers, Heras, ACA, and Agile Network India. As a passionate public speaker, Mr. Kumaresan has delivered over 100 plus talks at various academic and industry conferences, inspiring countless professional and students in the field of AI and digital transformation. We are delighted to have him with us today, and we eagerly look forward to his valuable insights and guidance. Let's extend a warm welcome to Mr. M.K. Kumaresan. Welcome you, sir.
Thank you, ma'am. That was a great introduction. Thank you about that. And thank you everyone for joining the session. Even I joined a little early. I could able to, watch the previous session for 15 minutes. It was excellent about excellent explainable AI. Thank you for that. So without any further ado, I'll start my presentation. Right. I hope my screen is visible to everybody, right?
Yes, sir.
All right. Okay. And yeah, so myself, Kamarizan, working for Google. I have an industry experience of 13 years. I welcome you all for this discussion. What we're going to do for next 1.5 hour or 1 hour. This is more about the real world deployment of AI systems. What we do in the real world with the end customer. As we all know, AI is buzzword everywhere. Every product or every project, what we work in academic, also we are try to incorporate AI as in one or any form, right? It could be from machine learning or deep learning or a generative AI. And for an industry perspective, we'll classify that into the complete AI lifecycle into two categories. One is provider, other one is consumer. As a provider, and what are the tools available and how we are delivering the AI solution to the end customer who are a consumer. These two categories we'll discuss little about it, and I'll show you some practical tools while you can incorporate, we can integrate your existing deep learning model or your data set, and how do you navigate and utilize the cloud services. That's the main intention of this session. And the agenda going to be, yeah, foundational one. So we will discuss about ABC triangle, what is about the ABC, and objective of today. So objective of this session mainly for the real world AI use cases. We'll take you know any one of the industry, because AI is not only specific to a IT sector. Now with the faster adoption, AI is being consumed by almost every industry, right? Starting from automobile to power plant to a pharmaceutical to a car manufacturing to any field. If you go, AI is being consumed, so AI is getting incorporated in all their workflow. And what is the foundation for AI with respect to the consumption and delivery? We'll discuss about the ABC. And then of course we all know it, without data there is no such thing called AI. And why AI is so popular, and what are the options, how we can do a data handling part, considering data engineering, data lifecycle management, and how faster and effectively we do with the cloud technology today for the customer requirement. So these are the agenda what I have prepared for today, and do let me know if you have any questions. And so we'll start with a brief history. As we all know, so we are in the revolution 4. So each revolution will change the huge impact and the major change in our life. Starting from a revolution 1, when the first time the steam engine got introduced, we got the complete transformation and connectivity happened from rural to urban, then followed by 1800 with the electricity and 1980s with respect to computer and IT technologies. Now all with the AI, the fourth revolution, and every industry is being consumed by AI. And this AI revolution is closely connected with IoT and also the human society, I would say. So other revolutions, I would, those are kind of a technical revolution, or a industry revolution, we may call it as. But this revolution, where we work and where we learn, where we do a exploration, it's more about a human society, what we do with the AI, and how we incorporate that into IoT devices. There we into. And I know you all might be knowing answer for that. I know you all are professors, and when the first time AI got introduced, and the reason I brought this question here, we all know that AI is not new. AI exists for so long. We've been using AI application for a longer time, but past couple of years, probably like 4 to 5 years, it is always in the hype, and we've been hearing the buzzword regularly. Technology is so dynamic. Almost, we started hearing all the fancy words, starting from data scientist to a prompt engineering to fine tuning. So these are the terms. It's relatively new to us. It never existed before, but after with the advancement of technologies, advancement of the power of AI, what it can bring to an end customer, this is all born. So why this popularity? Where it all started, and what is the connection with the industry use case? To answer that question, yeah, we all know that AI has been introduced in 1956, almost 67 years, 68 years before it has been introduced. By it is so popular for past probably 5 to 10 years. The reason behind the power of this ABC. The power of ABC, the reason if you wanted to incorporate or if you wanted to go with any real-time AI application to the end customer, you need to have a good understanding or good foundation or good exposure about these three terms. So if you wanted to have an artificial intelligence powerful system, you should have a big data and cloud computing. So big data is nothing but, I mean, you should have a golden data set with a large in size and which has a capability to handle the end-to-end data insights. And when the data is very large and big in size, to handle the data, of course, we would need a cloud computing platform. And maybe if we ask the question, what could be the AI tool what you use today, and most people they say the answer would be chat gpt or a gemini, or we use some of the generative AI or LLM model, unlike before. But before also we are using AI tools like map application or weather prediction or email spam filter. We've been using AI for a long time, but now whatever the AI tool or any foundation model or a generative AI or large language model, when we name anything which is related to what is cloud computing or big data. So we can't imagine today without big data and cloud computing, we cannot develop a the efficient artificial intelligence or AI system. We all agree that point. So I had summarized this into A is equal to B plus C, how the big data and cloud computing combines together to create a efficient artificial intelligence system. And we'll take the difference between the yesterday's AI and today's AI, and how we classify or how we narrate that today's AI is better than yesterday's AI. Then we'll take one particular differentiator, what it brings, the today's AI, the generative AI, what we use or explore today makes you feel more effective. Then we go with one particular thing and we go and show a quick demo, and you all will be having access to that portal with your Gmail ID. You can also do a demo along with me, and you'll have a good exposure, like when you do a real time AI based application, how we can create in a real quick. That's a whole agenda. I'm just summarizing that with the ABC and what we're going to do next. And so it's how the revolution is getting changed in the industry. And when you go with the traditional programming, when you wanted to interact with the computer or you wanted to develop anything with a computer, of course you need to talk to a computer in computer's own language. You should talk in a programming language. But this has been changed after the neural network, either with vision or a CNN, RNN. You can show an image, the computer can understand what exists in the image, it will take a pattern and it will react accordingly. But Now with the generative AI, no, you're not going to do a end-to-end coding, or you're not going to train a model with all the data sets or the data what you have handy. Rather, you're just giving a pile of data. When I say that, could be any form of a data. It could be a text data or image data or audio data or video data. So data could be anything. Multiple types of a data you can give as an input to a generative AI model. The model now has the ability to do a pre-processing. It has the ability to understand the pattern inside. It has the ability to train itself and just deliver the output to you. So that way we can differentiate the traditional deep learning or machine learning model to a generative AI model. So one differentiator here is the input could be anything, and it has the ability to train on its own. You need to give a logic, and you need to do a fine tuning and a customization with respect to our use case. Now, why generative AI? The same answer. So the generative AI is subset of deep learning, and if you wanted to make a computer to mimic like a human in a better way or efficient way, obviously generative AI is a solution, or generative AI is a trend. And the industry perspective, why it is becoming so popular and why it is in a emerging technology hype. The reason, every industry is working for of course, every industry or every business, if you take an example, they work for innovation, they work for a revenue, they work for a business profit, right? And the main challenge for any industry, if you take an example, the workflow automation is the main challenge. So the workflow automation could be any sector oriented, like from automobile industry to IT sector. The workflow automation is a real challenge. If you take any IT industry, the main challenge would be customer support, or the main challenge would be getting a resource available for your production. Those are the main challenges. So if you automate the complete workflow, then the organization will get a more time, and they will definitely increase their productivity. So targeting the automation is a goal for every industry. Of course, every industry is working on a particular problem to get resolved. When you wanted to solve a particular problem, the automation makes the flow very easy. The automation accelerate the flow. That's a whole idea. So the industry targeted the industry automation for 50% of their workflow automation should happen by 2040. But after this Gen AI, the drift happened from 2040 to 2030. 10 years, the prepone the drift. So that drift makes all the challenges, all the interest from every industry, and almost every industry they wanted to bring the AI. If you take an example of a call center industry, or if you take an example of like a web search or a e-commerce industry, rather they use a yesterday's recommendation or a classification. Now they are exploring all the available ways to bring AI, because they know the whole idea that if you bring a generative AI into the real world or into their production workflow, they could definitely achieve the automation 10 years before what they targeted for on a whole picture. I'm saying that's the main reason, the trend and the interest, the importance it happens in generative AI. Now, generative AI is today's AI. So, of course, if we are exploring something today, and if you are wanted to utilize or consume a generative AI today, we should have a little understanding about yesterday's AI, what exists. So, I just put few examples. The yesterday's AI, like a email filter, which will predict your spam and put into a spam folder, and weather prediction, which will do a prediction with the data pattern what you trained. Other one is a map also obviously a predictive AI. So yesterday's AI mostly it does a core task between a classification and prediction, right? Classification and prediction. Whereas if you go with today's AI, we have the additional two effective components, so that we are summarizing at understanding and generation. So we'll discuss about this understanding and generation, and we'll show you a quick real demo with respect to understanding what it comes under the understanding, and how do you interact with the AI system using some low code no code tool, and how do you develop a basic generative AI applications for any use case. So classification and prediction, which belongs to yesterday's AI, we've been using it. Now On top of it, additionally, we have effective understanding and generation, which is the main core reason why the generative AI is becoming so popular today. So understanding, it's a combination of your NLU and NLP. We will call it as a natural language understanding and natural language processing. And this is exactly like this lux picture. You don't need to interact with the computer in a computer's own language. Rather, you just give a prompt, just give a natural language to a computer can understand, the machine learning model can understand, and it will take the intention behind your prompt. It will pre-process the request and give an output to you. So that's a way you can accelerate the adoption of AI. So when we say accelerating the adoption of AI, earlier, the industry, every consumer used to develop mostly their own model in their own infrastructure. They build a server. They have their own data set. They train a model. They will develop a feedback loop. They'll develop a data pipeline. They'll monitor feature engineering, end-to-end data engineering, and the machine learning lifecycle they used to do. Now, with the faster adoption of this big data, the data engineering or data architectures, and also the faster adoption of cloud computing. So earlier, the cloud computing is considered as a cost-effective platform. When we call it as a cost-effective platform, every consumers wanted to use a cloud computing to save some cost. So if you host the resources in cloud computing, your cost is very less. We don't want to buy it. Whenever we use it, subscribe and pay it. So cloud was considered as a cost-effective platform. But today, the same cloud is treated as a revenue-generating platform. When we name as a revenue-generating platform, how the cloud computing is generating a revenue for the customer. So how it is doing that magic? Cloud computing comes up with all the machine learning models, all the generative AI models, and it has a huge computing power. If you wanted to use the value from your data, then the cloud computing is the easiest solution. You can go with any cloud computing platform. I'm calling the cloud computing platform are the providers. It could be from a GCP, from Google Cloud, or Azure from Microsoft, or AWS, or Oracle, or IBM Cloud, any cloud computing platform, if you take an example, they are the providers. Consumers are the customers or enterprises, those who use this cloud computing platform for their business use case. Now, more customers are using cloud computing platform to bring their data to a cloud computing, make the value from the data and get that into their business, increase the effectiveness, increase the production, or increase the more revenue in their business. That's a whole logic. The cloud adoption is faster than before. The reason behind, now cloud is being considered as a revenue generating platform, right? Now coming back to the like understanding and generation perspective. So understanding and generation, we all should be knowing it now by interacting with lot of AI bots happening today, or interacting anything today on the technology, say like a Google search or a smart TV or Alexa, Siri, such kind of voice based application. Or if you do any chat with Google Gemini or OpenAI's chat GPT, we do a communication or a chat with our own language. So it processes our own language and respond back to you. So English is becoming a new programming language, so that NLU and NLP is getting faster adoption with the generative AI, which default comes up with. That's a one core idea. The other one is the generation. So earlier, the model was primarily being used or consumed for a predictive analysis and classification. That all we know it, right? And now with a generation, if you are using a text model, the large language model, the text output it could able to generate. The same way, if you are using a multi-model, so multi-model has the ability to generate a text, to generate an image, generate a video, to generate a audio, and any output or code output also. Just give a prompt, it has the ability to generate anything. So the powerful NLU NLP and the powerful mechanism of a multi-model capabilities, which makes the generative AI unique and getting a faster adoption. Since it has a, it has an NLU NLP very popular, not necessarily whoever using generative AI model to be a code expert, could be a like a AI practitioner. Those who have a good understanding about model handling, those who have a good understanding about machine learning model life cycle, having good understanding about a prompt engineering, they could be able to develop their business use case. I'm just summarizing this slide. And if you take a little quick example about what we discussed with these four agenda items: classification, prediction, understanding, and the other one is a generation. From 2015 to today, where we are. So 2015, uh, we all know it. So the primarily the model which has been created, being used for a prediction and classification. But 2015 to 2020, basically after 2017, after the transformer model got released, what concept has been introduced is called attention mechanism. So we have a concept of encoding, decoding, it all started. Now 2022, it got more efficient with the diffusion, shrink the model from a large language model to a small model that has been started. Now what is happening with today, when data is becoming so big, every industry wanted to have a adoption with the AI to bring the data, get that value. That's a whole logic everybody's looking. I'll bring my data to a cloud computing, you give me a value back to me, then I'll make a revenue out of it. This is a whole logic. Then today's data, the data is everywhere. The data is then everybody knows about the data's importance also. Data is now no more considered as a fuel. Now data is being considered as a water, right? So if we used to call data is fuel for everything, now data is considered as a water. Data is becoming the basic need. Data is becoming infinite now. So having a data, consume a data with a generative AI model, and whichever the technology you wanted to consume, be with a natural language understanding for a conversational AI, or you wanted to go with the image classification and a computer vision, or you wanted to go with a predictive analysis, or you want to go with anything with a bioinformatics or a biomedical. Bring your data, consume a generative AI, customize or fine tune with your data set. Then your particular use case or a problem get resolved. That's where the place where we are. That's we will call it as exactly the AI race with all the customers. And same slide, I'm just summarizing the part. And today is more about the technology is bigger, faster, and cheaper, because you don't need to start from a scratch. Because earlier we used to spend a lot of efforts to handle the data engineering life cycle, from data generation to a data ingestion, data transformation, data serving, data storage. The whole logic of investing more time into a ETL pipeline, we used to spend a lot of effort and a lot of cost. Whereas now with a advanced options available with a cloud computing platform, this data handling part, bringing a data, setting a data pipeline, data pre-processing, applying a ETL logic, which is getting automated. So one time effort you need to do it, just insert a data into a pipeline, everything will be taken care. So whenever you need, you just go and fine tune your model. So that's exactly it happens for all the use cases. Now what we do and what kind of opportunities, or what kind of adaption is happening very quick with the generative AI. So we could classify that into these four categories. So these four categories are applicable for any cloud vendor or any cloud technologies, if you wanted to utilize their generative AI model into your use case. So the whole idea, you have a data, bring the data into a cloud, get a value back to your system, make a revenue. And how we achieve that? Earlier, the challenge was we have a huge amount of a data, but handling the data and getting an insight from the data itself a difficult task, and searching and understanding. It is data is not structured, and making a data in a structured format or a SQL database which is readable for all the input itself a very tedious task. So now with the generative AI and multimodal capabilities, now you don't need to give a data input as a structured data. The input could be structured or unstructured, or image or a text file or a PDF file, video file, we can give it. It has the understanding to pre-process it, convert them into a understandable way. The end result, it will make a vector database where you can go and extract it. And the next one is a online interaction become conversational. So it's a like we are the very best victim for that. And after getting adoption of these all popular generative AI tools in today's world, starting from Gemini to ChatGPT or any AI tool, if you take, you started feeling those are a personal conversational. Those are not like you are talking to a machine, right? If you talk to a AI bot and you started feeling those are a conversation, they understand your intention. It carry forward the past interaction what you have with the AI bot. That's is taken care. And the next one is fine, you have a data, you could able to extract the value from a data, you do a conversation. Next, of course, now models today have ability to generate everything. It has the ability to generate a text, image, so we can bring that directly into digital marketing, and we can bring that directly into a advertisement platform, that directly into writing a blogs, or directly into a social media. So anywhere you want to do a digitalization of your product, that is easily done with the generative AI. The last one is customize a foundation model. Yeah, you have a data, but you don't want to spend more time to develop your own model, or you don't want to spend more time to pre-process your data to ensure your data is on shape to handle with the model. Rather, bring the use case which you wanted to use. See, if you want to go with a text-based model, go and consume a Gemini or a GPT. If you want to go with a like a image-based model, go and pick any any CNN model or any mobile net model from open source. So that way, depends on the use case. We do have lot of open source model available in the market, which can be consumed directly using a API, or which can be consumed directly from any cloud provider where you have access. So this is the whole idea how we are consuming generative AI. And now, empowering the AI practitioner. So now accessing a generative AI also becoming so easy by using the prompt engineering and support. You could be able to directly access. And and those foundation model or generative AI model, what you access, what you integrate with your system, those also dynamically getting updated. You can utilize. So if in case they release a particular version 1.0, they may release 1.5, 1.2.0. With their advancement on the foundation model, you can go and enhance and go and improve your efficiency also. And so data management, of course. And if you go with a cloud computing platform, the main advantage here is the data size is unlike before. Data is growing exponentially. When I say exponentially, data used to be in a size of a lemon, then it was become a size of a cricket ball. Now the data what we handle in real world, it's a live data or a batch data, it's size of a football. The faster phase how the data is growing, it is soon going to be like kind of a football ground size. So the data what we have it today, per day the data is being generated is 463 exabyte. 463 exabyte is almost like a 1 billion, like a 1 billion TB, and 1 million gigabyte GB. So that much data is getting generated today. When it going to be like a thousand times more in near future to handle the data. I mean, who handles the data effectively, or who develops the application which handles the data effectively, will become a champion in that particular area. So there, that is where the place where the work and competition is happening. If you go with any cloud computing platform, so how much importance you giving for A to deliver a output, the same kind of importance you need to give for the other infrastructure also. What type of a data architecture we can develop for these use case, and what kind of a cloud networking we can provide it. And also handling a data which comes along with some undercurrents, you should be very careful about the security, data management, data ops, and you should be very careful about the securities and policies, PI redaction, that also needs to be taken care. And distributed system, the scalability, failover, high availability, and low latency, accessibility. So these are the major challenges when we develop an application, or when we are bringing that AI to a end consumer or a end user, we should take in care. And if we wanted to go global, wanted to create an application globally accessible with all the points what we discussed just before, and creating those in our on-prem or in our own server, it's practically a very tedious, very practically it's not a near to impossible task. So rather we go with the cloud. It is available ready-made. Bring your data, get a value, and which will covers the other infrastructure elements as well. Bring a data, taken care of undergrounds, taken care of your data engineering life cycle. All these will be taken care. All right. And before I go with the specific Vertex AI, I'll pause it here. Do we have any questions so far? Okay, I'll take it as no. So now we go with the generative AI on Vertex. So we little discuss. I mean, so far we discussed about the foundation, and we discussed about the relation between artificial intelligence, big data, and cloud computing, and what value and what changes it brings to our industry, and industry statistics. Why the AI adoption is so faster in industry with respect to the automation, with respect to the use case what we have, and the model adoption happened for last 15 years. Now generative AI and Vertex, which is specific to a GCP cloud platform. So we do have a multiple cloud platform providers. So I said you like we have a providers and consumers. So providers are the people, those who own the cloud computing platform. They will give the cloud computing platform instance to a computer. Consumers will consume and they will pay for what they use. Now the cloud computing platform comes up with a lot of it resources, and when we name it as a high level, so it has a own computing platform, it has a own networking platform, it has own storage and security. Compute, network, storage, and security, those are the primary core component in cloud computing platform. So which was the reason I told you little before, being considered the cloud computing is treated as a cost effective platform. Now the cloud computer is retreated as a revenue generating platform. When we name it as a revenue generating platform, it has to process your data and it has to make a value out of your data. When we call it as a value out of data, it has to make a model training or a generative AI accessibility, which is easier. So to do that, so in a GCP cloud platform, we have a like a solution or a suite called as Vertex AI. So Vertex AI, I hope most of you might have heard this term, or you might have worked on your project with the Vertex AI. And those who are hearing the first time, I'll give a little background. And so developing a model which consists of multiple stages, right? Handling a data, pre-processing a data, training a model, testing a model, doing a feedback loop, evaluating a model. It comes with a lot of iterations in the life cycle. To handle these all the iterations, we do have options. Either we can do all by our own, or we can automate all these things with the available platform in the cloud. So to do the end-to-end machine learning life cycle in a GCP cloud, they do have a platform. That platform we call it as a Vertex AI. So Vertex AI platform in GCP cloud, which primarily takes care of end-to-end machine learning life cycle, starting from data generation handling to data pre-processing to training a model to feedback loop, feature engineering, and evaluation, performance, inference. Everything will be taken care by Vertex AI. So before we get into dive into Vertex AI, so Vertex AI, if you use, I mean, similarly, we do have a other this AI accessing platform tool in other cloud as well. For an example, we're going a deep dive into GCP cloud. So the Vertex AI is not only limiting your accessibility to a generative AI model available in a GCP cloud only. So every cloud providers, they do have their own models, right? If you go with the GCP cloud, they have a Palm, Gemini, a Llama. There are multiple models. Lambda, basically. If you go with Azure or OpenAI, they have a GPT, GPT-4 kind of a model, and you have a diffusion models. And if you go with the other open sources, we do have a multiple. I mean, Meta, if you go Llama 3, multiple models are available. Most of the models are open source model. Some models are specific to that particular cloud providers. So if you go and utilize this Vertex AI in the cloud computing platform, the GCP cloud computing platform, it comes up with a model garden. This is a model garden. This model garden, a modern garden, has the ability to access the foundation model which exists in GCP, and also it has a access to access the other model which exists in other clouds, other open source. So going with the Vertex AI, you could have ability to access Google's own model as well as the other open source model. And you do have a generative AI studio. So generative AI studio, so the main core popularity reason is the understanding and generation. When we call it as understanding, the way we interact with the generative AI model is completely easy. So you just need to know a prompt engineering. You just need to understand your problem statement, your business use case. You go and do a interact with the prompt design, and you can bring your own data, fine tune that with the generative AI model. All set, you will get an output. And to achieve this application layer, the model garden, generative AI, foundation model, pre-trained, prompt design, these are all with the generative AI. But okay, some customers, they may say, no, I don't want to use a generative AI. Rather, I wanted to develop my own model. My own model has to be in my own network. I will not share my data to a generative AI model. For such use case, we do have a ML platform. It could be a auto ML, or you can create your own machine learning model. You can train a model, you can pre-process the data, deploy a model, you can take care of an end-to-end ML life cycle. So there are the multiple ways you can use it. But earlier, before this generative AI, before this model garden, generative AI studio, foundation, pre-trained, these are relatively new. When you wanted to access a generative AI model and fine tune or customize your own data set, even before the generative AI model, this is the or this was a core functionality of a Vertex AI, which is being used to handle the end-to-end machine learning lifecycle. All right. Now, this way we go here. And what actually it does, it simplifies the serving and tuning the large language model. And if you go with any IT project, if you go and work with any IT customer, and for an example, I'll give a scenario. And you know we all are using a mobile phones. We all use like network 4G or 5G every day. And if in case our network is having a hard time, and you are not getting a proper network at home or work, and definitely we will raise a complaint to a customer care. Once you raise a complaint to a customer care, and how the interaction goes, all we know. And so if a customer care experience is not good for you, if you started feeling your provider is not giving a like excellent service to you, so tomorrow you may switch to a different service provider. So it is provider's responsibility to automate the whole process. To automate the whole process, they will play with the media data. They'll bring the earlier data into a system. They will fine tune and with the generative AI. They may create a virtual AI bot. Next time you call a bot will resolve faster. If in case still you escalate to a human agent, also the human agent will assist in a way where the agent assist features or the human AI features will assist your live agent to serve you very effectively. Just to summarize, different people in IT organization or a machine learning project do a role, right? From a IT engineer taking care of the infrastructure provision, and developer primarily concentrate on a front end development or back end development, consume customer or consumer which concentrate only on the end result. Now, with the generative, I mean, Vertex AI, so this is completely taken care under your GCP project, and you have a UI where you can access the large language model, and you can influence all these, foundation model. And rather than showing the PPT, I'll just show you those are, in case first time seeing the GCP cloud platform. This will give an idea what I'm talking about. And this is the way we log into a cloud console. And when you go with Vertex AI, and yeah, so Vertex AI, so Vertex AI is a end-to-end machine learning uh, platform, I mean lifecycle platform available GCP cloud. So I'm into GCP cloud, the Google Cloud platform, accessing a Vertex AI. So Vertex AI, it comes up with its own dashboard which has the model garden. So this is the model garden which I was explaining little before, where we get the access to access all the foundation model. So Gemini is from Google, Imagine is from Google, Gemma. Then we have a Llama 2. Llama 2 is from a Meta. And if you wanted to go with the categorization wise, you can go and access Hugging Space, Meta, Mistral. So any of the providers models, you can directly access it. So this is the mod, and again go with the a language model. We do have a 73 language model where you can access it and integrate with your data. And if you, in case you wanted to go with a vision model, we do have a vision model find. So yeah, we do have a vision model where you can access it. And this way, like I'm just giving the high level idea, and whichever the use case you wanted to use, we can go here and you can access it, glada, and you can consume it and you can access it. And if you wanted to go with the cloud workbench, here you can create your own data set and you can go with the data set and play around. And this will give you a whole idea. And the other advantage here is, if you wanted to incorporate your machine learning models output to your dashboard or a front end application, or you want to retrieve any insight from a machine learning model, so rather developing a one more server, one more infrastructure, one more code base, in this cloud computing platform, we do have a accessibility to integrate with any APIs. So any APIs like we do have a computing platform where you wanted to own a computer, you can go with a compute engine. In a cloud computing platform, if you wanted to go with the serverless computer, we do have option cloud function, cloud run, where you can just go and deploy your code that will create a front end application. And this is the way the generative AI is being consumed right now. I'll be back here. Then prompt tuning, and we've been discussing about a prompt tuning to interact with the generative AI model, and just to give a instruction in a prompt, and how the prompt tuning is handled by a generative AI model. And fine tuning is more about bring your data and again customize with the generative AI model with a pre-trained, basically a generative AI model which was available. So the model what we explored in the Vertex AI about a Gemini or a Llama or Hugging Face, so those are the pre-trained model. Now in the phase of a fine tuning, we'll bring our own data and customize with our data with a pre-trained model, then we will use it for our use case. I'll give you one real-time example scenario and we'll do it together. And distillation, so distillation is all about deriving a the smaller model, deriving a student model from a parent model. That's what like it illustrate more. And with a few short prompt examples, prompt you giving to the model, from a generate teacher model, you can distillate, you can filter them into a student model which is more accurate and more close to a data set what you bring from your industry use case to a generative AI foundation models. And if you wanted to utilize any of these generative AI model, all we know now, the model is no more large language or only a text handling. It is now more into multi model handling. So multi model handling is more about text, code generation, image, video, code, embedding, or co-piloting. All will be taken care. Right. So now what we can do here, and I'll just give you one URL, Google AI Studio. So before I go, and right, okay. So what we can do now? Uh, I'll just right, and uh, there could be a one use case we can integrate. We can think about it, and we'll just try to explore how you can utilize the Gemini 2 or the latest generative AI model, how we can make a AI bot in real quick time. And the same example which I told you just before, and will it start with us. And if in case, and we have a, like working, we as a, I would say like a end customer, and we wanted to automate a call center. We wanted to automate a contact center in a company called Demotel. I'll just give a some dummy name, Demotel, like Airtel or Aircel. We'll call it as a Demotel is organization. If any end customer calls the organization, the telephone number, they'll be having definitely a toll free number. So the toll free number would be I'll say 122. Then definitely after dialing the number, it goes to a IVR. So IVR will definitely prompt for option one. Then IVR will prompt for option two, option three for your respective option. Then after I passing IVR, uh, it will go to a agent, right? After pressing 9, it may go to a human agent, but not always the time your human agent will resolve your problem, right? So most of the time when you talk to your human agent, you may get more irritation, irritation, and you may ask your human agent, okay, raise a complaint or escalate to this to your lead. Then they may connect to one more human agent. If he able to unable to resolve the agent or a call center executive, it may go to their team lead. So most of the time you will not get the resolution. They may buy your time, says that, yeah, I raise a complaint for on behalf. It may take 24 hours or 48 hours for the resolution. So this is the the real experience. Most of the time when we interact with the customer care, we may feel it. Now we have given us a task to automate this workflow. So how we can automate here? The main clue would be all the calls in the call centers are getting recorded. That all we know. So every time when we interact with the customer care executive, you may get IVR says that your calls are getting recorded. So whenever you interact, now this call center may have all this recording in its database. So if you wanted to bring a generative AI model into this particular use case, what best or what is the easiest way you can incorporate or give a solution to this particular use case? Let's see the solution. This is a problem statement, very simple, and the company named Demotel having a hard time to give a best customer experience to the end customer. End customers calls are day by day getting increased so much, huge volume of calls. Their agents are unable to solve the problems. Customers are getting frustrated. The same time, the agents also getting frustrated due to the higher call volume. Their attrition also more. Now they got a consultation to bring a generative AI to automate this workflow. How do they automate the workflow? By using a generative AI is a solution. So the solution part, we will from a recording, what we do, recording is nothing but in our use case, this call recording is a actual data. So from this recording, we get a transcript by applying any speech to text API. We'll get a transcript here. When we get a transcript, and from a transcript, then you will call the transcript as your data set, your own data, right? So it's a, like a data of a Demotel. So with this data set, now we have a cloud computing platform. Inside a cloud computing platform, you have a generative AI model. So this is a Gen AI model we say, and so this is a cloud computing, and what we do, we just fine tune the actual data for a demotel. So demotel recording being considered as a demotel transcript, demotel transcript now being considered as a data, as a text format, it's a data set. Now with the data set, you are going to customize or fine tune a generative AI. So after creating a generative AI, then for the call center use case, we have a three solutions on, on a high level, I would say. What are the three solutions for this particular call flow? Who all are getting involved? The first one is the end customer here. So he's the end customer who interact with the call center, customer who call the customer care line, and who will interact with the call center. The second one would be a human agent who is an employee. So third one is a business user who will be running a business. He's a VP or a director or a CEO of the company who will be looking at the business report. So these three people are playing a vital role, starting from a customer and to a human agent to a business people. So we have a, yep, a different color. Yeah, business people, the business people. So these three people are involving in this workflow. And as we started with the first slide, every industry's objective or a target goal is they wanted to automate the workflow. And if they could able to automate the workflow by 50 percentage here, they could able to achieve the end result. I mean, that end result in the sense they could able to achieve their automation. Now, to bring the automation using a generative AI, so now we converted their call recording into transcript, converted them as a data set with a pattern. Now we go with the generative AI. So generative AI output has to go with the customer first. Customer has to get satisfied with the result. Then we do have a human agent. Then we do have a business pupil. For that, we may go with a different solution available in this cloud platform. For example, to solve the end customer problem, you can create a virtual bot, AI bot. You can call it as AI bot, which will do an interaction with the end customer, which will be effective than a IVR and call holding time, because it is faster than a human, which will extract the data, which will extract the past interaction, which will extract the pattern and give the response back to the end customer. If in case still the end customer escalate the call, okay, fine. Out of 100 calls, 95% calls are handled by bot, or 90%. 10% calls still getting escalated to a human agent. So human agent, when they get a call, then if you bring AI into the loop for the human agent, they also feel more faster, more smarter. When they interacting with the end customer, they may get all the solution in their screen. Okay, what he is asking, what would be the solution? Then your attrition control also would get reduced. Your productivity get increased in a demo model. The last one is the business people. Of course, when you have all the interactions, when you have a human agents are effectively faster, then this all the interactions are happening in the cloud. These all the interactions are analyzed by AI system. Then you have the end-to-end conversation, end-to-end data available in your cloud computing platform. You can directly create a insight report from this particular data. I mean, these are one of the use case we could think about in a high level, how the generative AI foundation models are getting incorporated into every industry use case. Take an example of a call center. This was a problem statement, the poor customer experience, and customer, human agent, and business people. Those three people are in a loop. When we bring AI into the system, this problem is getting resolved. This is a solution on a high level how we can give. Now, when we give this solution to a customer, AI bot or human agent and insight report, earlier with before generative AI also this is possible. People are doing it with creating the own machine learning model pipeline, writing a code. Now with the generative AI, so rather doing all this by applying couple of prompt here, prompt engineer sitting here, he could able to achieve a prompt engineering. So they will say like a, this is prompt. By applying a prompt engineering prompt, you could able to fine tune or customize your generative AI model with your own data set. You could able to deliver all the required output. This is the way an high level works. And how do we do that with one of the cloud we've been discussing about the Google Cloud. So for that, I given you an example of this particular window. Is it accessible to you? The link which I gave you, you can just log in with your Gmail ID. Can somebody confirm the AI Studio? So you can also explore, at your free time. I'll just show you what actually it mean by. And to do that, in a same cloud computing platform, we do have a we do have a option called as a dialog flow. It is one of the tool available or a solution available in the cloud computing platform, where you could able to create an agent. Now, assume in a way, uh, we discuss this problem statement, we found the solution, we're going to develop with the generative AI, right? Now, the question here is, so most of you here might be seeing this dialog flow, this tool as a first time. Hope you agree with me, right? You might or might not use this tool before. You have no idea what is this tool, how do I use it? And generally, if you don't know a tool, or if you don't know a console how to operate, what we generally do, we do a go internet search, we'll go with the documentation, or we do go with some YouTube video, or you go and learn something with online tutorial, then we come back and do it. That's the way generally we do. And now, with the multi-model capabilities of this generative AI, so that will give you more personalized experience. You feel like you have one tutor sitting next to you, or you have a subject matter expertise sitting next to you, looking at your screen and guiding you exactly. Does it make sense what I'm trying to say? See, now I'm sharing my screen, you all watching my screen, and if I do some next to next option, if I do some prompt and play creating a bot will respond back to me. So you may feel, yeah, he already having experience, he knows a tool, he knows how to operate it. As a novice person, as a beginner, how do I get to know how to use a tool? For that problem also, now generative AI is giving a solution. For that, I'm going with this generative AI studio, and this is the studio where I'm accessing a Gemini 2.0 flash experimental model. This is the multi-model, and I'm just doing a grounding with Google search. And so when we say a 2.0 multi-model, that means to say the multi-model has the ability to handle the text input, image input, or audio input, any type of input it could able to handle, and it could able to respond. Now, and what I'm going to do now, I go first. Yeah, I go here, stream real time. And if you are accessing the URL, you can also try it out. And you can try it out for any use case. I'm sharing my screen. I'm sharing my screen to Gemini, and I've started interacting with Gemini. And hi Gemini, can you hear me? Mhm. Okay. All right, so what I'm trying to do now, so I'm just walking through the advancement and real-time use case of a generative AI in industries. And as part of it, I landed with one particular example to automate a call center. And I plan to create a AI bot using Google technologies. And I wanted to take a help from you. And Kelly, help me out. I have no idea about where I am today. So yes, that's right. And one question. How about participants? Are you able to listen the sound from Gemini also, the AI bot also, or are you able to hear only from me? Can somebody confirm?
We are able to hear you only, sir.
Yeah, we are able to hear you only, sir.
You're not able to hear. Okay, fine. Give me a minute. I'll see. I can bring both. This mic.
Okay. Hey, Gemini, are you there? Okay, I just want to ensure, like the participants are able to hear you. And I'm just doing a test with you. Can you see something? Participants, are you able to hear or no? Still. Gemini, just hold on, not to you. This question is to participants. And can somebody confirm for participants? Are you able to hear? You able to hear Gemini voice? Can somebody confirm? Give a thumbs up. Oh, it seems like, yeah, somebody has responded. All right, let's go with the proceedings. Yeah, I'm into dialog flow. So should I need to click create agent? Okay, I do that. I create a demotel was my use case. I create a demotel support agent. and just give me a watch. I go with the generative AI playbook. I do create, and what I do, uh, that's right. That's right. So what I'm going to do, okay, so I'm just going to create a prompt, and can you create? This is my requirement. Can you create a prompt for it? I will put it over there. That's right. This is my requirement. I just pasted you. I wanted to put the prompt here with the instructions for a generative AI playbook. Yep. Are you doing it? Or I can go with the prompt gallery. Okay, I had created a prompt. I go with the prompt. Okay, I share this. uh, Okay, let me reshare my screen.
Okay, I can see your screen now.
Okay. No, I'm just sharing the whole stream to my participant. Okay, this is the prompt what you created. This is for a demo tell. All right, and yep, and mhm. Okay, so I want to know about the data store. So data store is primarily for putting your own data, right? Looking at my example, this is the data set or a data from a demo tell. This data I should add into a foundation model. Am I right? Or okay, let me. Mm-hmm. All right. So I just created with the existing prompt. Let me test it out. Hi, I have a issue with 5G. Let me see what the prompt is here. It is taking the prompt. It is understanding what I need. All right, I think I'm good. So I had given your link to my participant. They may spend some time to explore you. Thank you, Gemini. Thank you. Thank you. All right. All right. So let me just back. And yep, so this is what the demo I wanted to show, and the problem statement what we highlighted here, this is completely about you know completely about a call center use case we've been discussing, and we are a problem solvers. Bring your problem along with your data with the generative AI. By doing a API integration or by doing a fine tuning, we will get a solution for you. In this use case, okay, fine, we got a data, we got a generative AI platform or a cloud computing platform, but still, and if we are really expert, then we could able to directly do that. But now with the power of the multi-model capabilities of the foundation models, what we can do it here, we could able to create or take assistance from your multi-model, and multi-model able to resolve all your problem. So I just shared my screen. It's like you feel like after sharing your screen, and you feel like the AI bot is sitting next to you looking at your monitor. That is what exactly it happens if you do a And let's see what and I do a stream. I go here. I ask my Gemini. Hey Gemini, are you back?
Okay. It seems like you are trying to do a live stream, and there is a video call going on with other people. Is there
Exactly.
anything specific you would like to do
No,
with
that's
that
fine. These
stream?
are participants on the webinar.
All right. So you are
Uh,
indeed.
I think, yeah. So this is the link which I gave to you. This is completely free. The participants, you can go and explore with your Gmail, and you can also stream your screen and whatever you do, your multimodal capabilities has the ability to understand with this image, and it will able to uh, guide you what needs to be done with any work. Not necessarily to be a uh, to be a project work with the Dell for a cloud computing or anything, and Google and AI Studio. Right. So we can just watch this particular clip also, which will give more idea what. All right. So just to be back with the presentation. With the Vertex AI. So we will explore the Vertex AI further when we have hands-on followed by. Now, so far, I explained you all about the Vertex AI model platform, model garden, and how we utilize the cloud services and capabilities to give a solution to your problem, bring your data, and get the value from your data. All right. And this demo is over, and I think that's all from my presentation. And do you have any questions? Feel free to ask me. Thank you. Hello everyone. So welcome back, and now in the second session, and what we gonna do. And the first session, we discussed on a high-level use cases in the industry with respect to what is required and what we can, how we can achieve using cloud computing platform. And we discussed little fundamental about the ABC triangle and the exponential growth of data engineering life cycle. We discussed about the yesterday's AI and today's EI. The main code differences are generation and understanding. And then we explore the Vertex AI a little bit. So Vertex AI is the end-to-end platform, machine learning platform where you can do end-to-end machine learning lifecycle available at Google Cloud Platform. See now, what we are going to do, we do a real-time hands-on with a deep learning model, not with a generative AI model. So generative AI model, I just showed you one example of accessing a Gemini 1.5 Pro, taking a help from Gemini 2.0, and for a call center use case. We discussed briefly about problem statement. What is the main challenge of a imaginary company called Demotel, and how do we automate the workflow using generative AI based solution. Now, this example, let me just log in with the cloud computing platform, and yeah. So this all you know it, right? So those who are accessing first time the cloud computing are basically a GCP cloud, and I believe you might have accessed it. If not, I'll give it a high level view, and we'll start over from there. So basically, if you take a cloud computing platform, we can access the any cloud computing platform in three ways. And what are the three ways we can say? And let's give an example what you're going to do before we start. Right. See now, this is the cloud providers, and who the cloud providers are being consumed or who are going to access the cloud. We will call it as a consumer. So the we will call it as a providers, and this we will call it as a consumers. Consumers might be the individual consumers also, or say individuals also can consume a cloud computing by subscribing a cloud by creating your own applications. And for a providers, the examples of GCP, which is from Google, then you have Azure from Microsoft, then you have AWS from Amazon, and you have a Oracle Cloud, and we do have many other cloud, IBM Cloud, many cloud. And consumers are the people, those who access these services. When we call it as a services, and we have major services available in the cloud computing platform. The core services are the compute services. Compute is a service where you go with a virtual machine, or the compute instance, or you go with the GPU, TPU, and etc. And we do have a storage, the next core component. First one is the compute, second one is the storage could be a file storage where you save and dump your file, or it could be a database storage also. We can save a database storage with respect to your requirement. Then we do have a networking, we will call it as a cloud networking. And we do have a security, so where we define our roles, and the rules, policies, and the put the networking firewalls. So these are the core services available at any cloud computing platform. Whereas in our use case, we're going to take an example of deploying deep learning model with cloud services. So to deploy a deep learning model to a cloud services, what we would need first what we would need first, and how we are going to achieve it using Vertex AI. So that's the exercise I'm going to show you. And these consumers might be any IT companies, say like you may consider an example of DPS, or you can consider an example of SRS, or you can commit EPM. Any company, and also the individuals. Individuals also can consume a cloud computing for their requirement, right? So this way the cloud computing is being consumed. Now, for a deep planning, deploying a deep learning, when you go with the deploying deep learning model in the cloud services, what are the things we are going to do? What are the things we would need to deploy a deep learning model? What we need? So to answer the question, first, of course, any model you want to deploy, you need a data set. So the data set you are bringing from your industry or your problem, or if you don't have a data set, you can synthetically create for a lab for a demo. But data set is primarily. Then you need to have a compute platform that we all know, compute platform. I mean, this also goes with the same logic what we discussed little before. A is equal to B plus C. Artificial intelligence is equal to big data and cloud computing. Basically, this data set is your big data. You can just I'm just giving an analogy. It will be a cloud computing. Then we need to have a model. So when we call it as a model, you can go with a pre-trained pre-trained model which is available in the cloud computing platform, right? So now, and also some other services, other cloud services, if you wanted to use other cloud services. When I say other cloud services, you may wanted to develop a front-end application, or you wanted to develop a web server, or you may want to develop a API services. Anything if you want to develop, after developing a model, then you could able to access those services exist in the cloud platform. Now, these are the providers. How I go with one example, those is the GCP. So GCP, we have a computing platform starting with compute engine to virtual machine, and there etc. Many we have. Then compute platform, and the data set will create. Then model. We may use Google's model or any other open source model using model garden, so that we just discussed before. And then other cloud services, you may use a cloud run, or uh, cloud function. So cloud and cloud functions are the serverless computers, which is available in the cloud computing platform, which are being consumed for your applications. Basically, if you want to deploy a code base, you no need to create an instance or a computer or infrastructure. Just go to this cloud run or cloud function, deploy your code, rest everything will be taken care by this application. Basically, these are the serverless computers, and this is the server computer where you are creating an instance and all the typical machines. Model garden is a place in a Vertex AI, so where we are going to access the Vertex AI and you are going to train a model. Are we good now? So this is a use case, and in this lab, what we are going to what we are going to do here in this okay, share this views tab. It's okay. So what we're going to do here in this lab, we're going to create a text classification deep learning model using model garden. So to do that, of course, we know we need to have a data set, and we need to configure a model using model garden. And if you wanted to go with the testing train using AutoML model also, we could be able to do that. Now we go with the first step. Step one, we're going to create a data set. So before I go there, this is the way the dashboard look like. If you want to access the cloud computing, there are multiple ways. You would say the three ways you can access the cloud computing. One is using a UI, what we are accessing it. Other one is the CLI, command line interface. Either you can use it UI itself to access a command line, or you go with your computer, your command line, where you can access the cloud computing project using your computer's CLI. The next option would be a API services by having a API access key using any API tool like Postman, or any API tool, you can able to access the cloud computing platform. Now, and these are the two ways. One is UI, what we are exploring. The other one is the the CLI part. Just giving the idea. Now we go with the Vertex AI. So Vertex AI is a platform what we're going to explore, and we want to create. We are going to create a classification model using a deep learning. So this our task could be text classification using model garden, right? So now, right, okay. Vertex AI platform. So Vertex AI is platform is a end-to-end platform where you do a entire machine learning life cycle. So in this example, we're going to create a text classification deep learning model along with your database, and we're going to test it out. Now, to create a database, we go to a Vertex AI, create a data set, and you'll call it as a text classification single label. So this is a way. If you go with our Vertex AI, so UI, you have an option to create a data set. So data set, and you go and create a data set here. When you go and create a data set, the data set could be anything. It could be a image or a tabular or a text or a video. So you can go with any type of a data set what you wanted to create. And for us, basically, we are going to create a text classification deep learning model. So I am selecting text single place classification. Rest everything I'm going with the default one. I'll create a database data set. Once I create a data set, it will ask me to point to a it will ask me definitely to upload a data. So to upload a data, we have a multiple options. Either you can upload it using UI, or you can go with the cloud storage bucket. You can able to access it. All right.
Sir, one doubt, sir.
So, madam, yes, ma'am.
Sir, if the data set is available in the Google Drive, is it
Mhm.
possible to connect there?
Dataset is available in Google Drive,
Yeah.
and you cannot directly access the Google Drive from GCP Cloud Platform. What you
Okay.
can do, either you can download into your local computer, from you can upload it. If not, you can transfer the data into a cloud storage bucket. We will call it as a GCS bucket. From there, you can upload it. Basically, for this data set. If you want to directly access the data set from a Google Drive, Google Colab is the easiest way. So Google Colab is a platform where you go and open a notebook. You can point to a Google Drive. And here, what we're going to do, we're going to create a workbench. And a workbench, you're going to open a Jupyter notebook. In that Jupyter notebook, we are going to upload your data set. So that is something inside your cloud platform. But Google Drive is something outside your cloud platform, that is over the internet. So you cannot directly transfer from Drive to your data set. Either you can upload to local computer and do it, or you can put that into a GCS bucket inside the cloud computing and you can do it.
Okay, sir. Okay, sir.
Okay.
Thank you, sir.
Fine. Thank you. So now I go with a single text page. It will take couple of minutes to create the data set, and then we will be pointing to a the pre-installed GCS bucket. I'll show you, ma'am, after this step. I'll show you how I'm pointing a a GCS bucket storage path to point to a data set. Now, so till the time it gets create, we go with the Vertex AI model garden, and we go in and verify what are the natural language APIs, and we'll see those APIs are enabled. So we're going to use the cloud computing platform Vertex AI. I go with the API services. So this API and services are the individual services for individual APIs. And so for this exercise, we wanted to ensure the Vertex AI API has been enabled. And also we need to ensure the compute engine API also enabled. So now we could see the Vertex AI API, which is already enabled. We'll double check the compute engine API also. So this is a place where you go to a API and services. We can double verify what are the APIs are enabled and what are the APIs are active. So we can double check that. Now, if you go with the compute engine, yeah, we could see there is a compute instance I had created. to create a compute engine. So compute engine is nothing but it is a local machine what you are creating on a cloud. And if you want to create a cloud compute engine, you go here, the default setting and the default specification. If you wanted to do any change here, you could able to do that. And if you wanted to change the operating system, so in this template default it come up with your Debian operating system. If you wanted to change the operating system, say like I don't want a Debian, I want to go with the Ubuntu, you can go with Ubuntu operating system, and you can able to create it. So I just created a computer. So this is just a pre-installed instance which has created here. To access this is a Linux system, so I'll be accessing it over a SSH. So to access a computing platform, when you click SSH access, definitely you will get a CLI which has been open, where you can do all the operations with the API keys and everything. So now our data set still it is getting created. In the time we'll go to a Vertex AI tab. So Vertex AI, and you go with the Vertex AI. It's our own AI platform where you do all these things. So Vertex AI Studio, we have a model garden and Collab Enterprise and prepare data, model development, deploy and use. So this is self-explanatory, right? Starting from handling a data to train a model, deploy a model, everything is taken care by this Vertex AI model garden. Now we go with the model garden. So model garden is the option. It's a garden of multiple models where we get the access to use any of the GCP's inbuilt or pre-trained model along with the model which is available from our other providers and open source as well. So now let's explore till the time when the dataset get created. This is something what we discussed a little before. We have language model, we have a vision model, a tabular model, and many models. So our use case here is the text classification using a machine deep learning model. So we go with the text classification, and we go with the uh, yeah. So we go with the text model. What we have it here. We have a Gemini 1.0 to Gemma Llama 3 and Translation LLM. And we have a couple of models. The Gemma is from GCP, whereas the Llama ATAL from Meta and Mixtral and Palm 2. There are multiple categories of models are available. See now, to access any of these model using your code base, you definitely need a API key. So what does that API key mean by? And just the we talk about that API one, and if we are accessing a cloud, is that my screen visible? Let me reshare my screen. Okay. All right. Okay. So now screens. I just reshared my link. All right. So this is what I'm explaining. So when you wanted to access anything with the cloud computing from your code base, from your model, you would definitely need a API keys to be created. So these API keys are inside the cloud platform. So these API keys which will give you AAA authentication and authorization to access it from any system. So now we are going to create a test classification model, and we're going to create our own the code base using a workbench, workbench is a virtual machine available in cloud platform. For that we would need a API key. How do we create a API key here? We can go to a cloud console, and you can go with the APIs and services, API and services, API and services. Here we go with the credentials. So and creating a credential. So creating an API key, basically you are creating a key or a credentials, and for a other system which is outside GCP cloud or outside this particular project to access the resources. I just copied the key and this key what we're going to use it on your instance as well, accessing it. Now connect to virtual machines and SSH. It's a virtual machine. We go with the text classification. Ah, so SSH we already open. It's a compute engine. We go with the compute engine. We connect to SSH. Once we connect to SSH, it will show you the CLI prompt where we need to export the key what we just generated from a cloud console. So we go with SSH and we export the key. Once we export the key, and what we do, we create a JSON file and we'll put the content here to submit a written JSON file. We will going to test a natural language API for a sentiment analysis. This is text classification. I'll put a command over there to clarify that. Yes, I'll just say that. Just ensure, okay, got saved. Then I go with that and API request to call the command because we already given the API key. Let me just call that call command. Result. Let's try to print the result. Command result dot JSON. And you will get a response like that. If you notice that we get two types of sentiment values, sentiment for document as a whole and the sentiment broken down by sentences. Okay, this matches with what we have seen in the model garden as well as in the documentation. It has a score between -1 and 1, and which defines and how the sentiment score about the JSON what we had created. And if it is -1 and the negative, if it is the positive one, it is positive. If the magnitude value is 0 and sentiment is a statement, but it's kind of a neutral regardless of being positive or negative. So we just created a JSON file and called that natural language API, so which is the API being called out. And if you wanted to see what that API does, we can go here with a language API. Again, natural language. SSH. Yeah. Well, remove that the earlier JSON and we'll create a new one. And here with the following changes. And for an example, so let's see the file. So let's so now same way classification if you do. Let us see the classification. Count result. And, so if you notice now, and it does a classifying the article title into different categories, but it not predict publisher of the article as you hold. So now it says it is a classification. This statement with respect to the library and with respect to the data what we gave, and the data which inside was Google's plan to future work, privacy, robots, and balloon walls. Something I just given. Now, what categorized this data, and it predicted the classification. Okay, it's something related to science and engineering about the text what we gave. Business news is like this is a confidence, this is a confident, and about technology news, internet telecom, but it has a more confident about science and engineering. So it has predicted with the data which has been pre-trained with the API calls which we called out for the classification and sentiment analysis. Now we go and see the data set. There is a creator now where text AI, and data set. Yeah, this was the data set what we just created, but we have not added the cloud storage bucket. Yeah, this is a database I was going to. So we go to our Vertex AI. So after into our Vertex AI, we go to our data set what we started a little ago, and we go to yeah, this is a place. And when you try, yeah, ma'am, you asked me this question. When you wanted to upload a data, so default we get these three options, and you can upload a text document from your computer, or you can import a file, the tar file from your computer, or you can do it from a GCS bucket, not actually from a drive. This drive is completely out of a GCP cloud, which does not communicate, together in between. So now what we do, we just copy the file path. Where is the file path? Okay, file path. So there is a file which has been added here. If we wanted to look into that file path, it should be part of our GCS bucket. So you type GCS. This is the cloud storage bucket available in GCP cloud. You go with the bucket. This is the bucket. In this bucket, I had uploaded the data here. So configuration. This is a file. A platform is the file which I have pointed. So we'll do a continue. See now this dataset going to take a file or import a file from the value where we place the GCS bucket. Let's go and do a SSH in the same instance, and see. believe we could be able to do a model training once after the data set is ready. So meanwhile, I'll just show you text AI. So this data set is still getting created. Once we have the data set got created by accessing the GCS bucket, we will get an option to train a new model. And while training a new model, we have a feasible options like using AutoML or a custom ML. There we can select a new model which you wanted to do. Then we do a start training a model. So once after do that, so that model what you choose, we just tested with SSH by accessing the GCP natural language API console. Now uploading a data set. After uploading a data set, you are pre-training that particular model or API using the data set what we are uploading it. Post that, we could able to test the performance of the model by using your data set. Let me just see if that happened. Still happening. Share that. Still happening. Export. Data set. It's still showing import. So once this import is successful, we could able to train a model using the natural language API available in our code, which we had tested in the compute engine instance. So the import is happening. Let's wait for a couple of minutes and see. Just to recall what we actually doing, and here the first the discussion about real-time use case, we had concentrated most of our discussion related to generative AI and using the no code low code tool. How do we uh, access it, and how do we consume it using the latest Gemini models. And we had taken an example of these Gemini, example of a call center, the problem statement, and we started evaluating the prototype for fixing the solution and providing a solution for the problem statement, starting from collecting a data set from their existing recording, convert them into a transcript. After converting them into a transcript and feed them into a pre-trained model. After giving them into a pre-trained model, then you have an option to create a bot. You have an option to go with the human agent assisting features using AI. The next one is you could go with a business dashboard, which will give more information to a business user. And now this use case is not going to do it, and Gemini 2 also we explored. And while sharing your screen, it's a multi-model. It was able to understand the screen, the screaming, and it could able to help you in a very real-time nature. And the same second exercise, again with the vertex ER, we explore the foundation and basics of Vertex AI. It's an end-to-end machine learning model lifecycle management suite available in GCP Cloud. And when you wanted to access the GCP Cloud, and so we need a API key to connect with. So we went to a Vertex AI. We explore the model garden. So model garden has the capabilities of handling Google's own model as well as the other models what it exists. So this is what we were discussing, an open source model and other providers model. And then we started creating a data set and pointing the data set to the storage, the local storage bucket in GCS, and the GCS import is still happening. Meanwhile, what we did, we had created a compute engine instance. Basically, you created a computer inside your cloud computing login, then you accessed using SSH. After connecting a Linux compute engine instance using SSH, we uh, uh, imported a couple of JSON file and accessed Google language, natural language API, and evaluated when you calling those APIs directly with the sample file, how the output got predicted, how the output got classified using a text classification model, which present inside the natural language API. So that is basically a deep learning model. Now we waiting for our data to be imported to access or train a model with our own data. And since it is taking a little more time than expected, and let me just pass. And do we have any questions for me so far? What we doing? Any doubts? And to get access to this kind of a cloud instance, you can activate using your Gmail account, and we will get 90 days validity period with a credit where you can explore it. And but the logic or architecture remains same for any cloud computing platform, but specific to GCP, we'll call it as a Vertex AI tool, where we will be developing end-to-end machine learning lifecycle. This is still happening. Once after the import successful, and we could able to directly train a new model using that API and select AutoML. Once after training a model, and we could able to run or deploy that model into a serverless application. And post deploying serverless application, we could able to test the text classification in our own console with our own data, what we trained or customized on top of it. All right. Since it is taking little more than expected, I'll go back to the screen. Stop it. And this demonstration, the step-by-step guide, and after this uploading your data set successfully, and what are the options you do for training a model, and how do we get a output. And I'll share you offline. Okay, so once it completes, rather than you write. So I understand you have a exam at 6:30. Okay, so this I'm concluding my demo. And if you have any questions or queries related to Vertex AI model garden or a GCP cloud, how we created, how we accessed, do let me know. Thank you.
Dear participants, you are welcome to ask questions to Kumaresan sir, who is ready to address them. Kindly ask your questions or post your questions in the chat box. Dear participants, any questions? You are welcome to ask questions to sir. Then shall we conclude the session or any questions from participants? Then I request Sindhal Selvi ma'am.
Ma'am.
You have to deliver the vote of thanks, ma'am.
Okay, ma'am. Respected Mr. Kumaran sir, esteemed faculty members and dear participants, it is with immense gratitude and appreciation that I stand before you to deliver the vote of thanks for this enlightening session. On the behalf of SRM Institute of Science and Technology, Ramapuram, and the Department of Computer Science and Engineering, I extend our heartfelt thanks to Mr. M.K. Kumaresan, Cloud Architect, Conversational AI at Cloud India Private Limited, for his valuable contribution as a resource person in this AICT sponsored 6 days online ATAL faculty development program on transforming industries with AI, deep learning breakthroughs, and real world applications. Sir, your expertise and deep insights into real world deployment of AI systems and deploying deep learning models with cloud services have provided us with a wealth of knowledge. Your session was not only informative but also highly engaging, helping us bridge the gap between theoretical AI concepts and the practical industry applications. We deeply appreciate the time and effort you have taken to share your wisdom with us. Your passion for AI, deep learning, and cloud technologies is truly inspiring, and we are grateful for the opportunity to learn from a leader of your caliber. We also thank AICT and ATAL for enabling this wonderful platform, our management, faculty members, and participants for their active engagement, and our organizing team for their seamless coordination. Once again, thank you, Mr. Kumaresan, sir, for valuable time and contribution. We look forward to more such collaboration in the future. Thank you, sir. Once again, thank you, sir.
Thank you so much, sir. And dear participants, once again, thank you all for your active participation in all the session. The assessment test is scheduled from 6:30 p.m. to 7:30 p.m. today, and all are kindly requested to complete the assessment test through your ATAL participant portal using your registered email ID. As per ATAL guidelines, it is mandatory to attend the test and achieve the minimum score of 75% to qualify for the certificate. Then after the completion of the test, the feedback and validity section will begin at 7:30 p.m. Group photo also be taken in the session. Then we encourage all the participants to join and share your feedback on this FDP. Your active participation will be greatly valued. Thank you. Thank you all.
Thank you, everyone.
And dear participants, the feedback link for the today's sessions are shared in the chat box. All are requested to submit the feedback before leaving the session.
Madam, the test is to be appeared only on the ATAL portal, na?
Yes, ma'am. Yes, ma'am.
And the time window is fixed 6:30 to 7:30.
Yes, yes, ma'am. Yes, ma'am. It is for
Okay.
1 hour.
No, but can it be flexible? I mean, for 1 hour can.
Already it schedule Atal portal in this coordinator portal. I will schedule the tested because the schedule itself it is a standard time 6:30 to 7:30 and also schedule it from 6:30 is for
All
1 hour.
right. Thank you.
Okay.
ஒரு 6 மணிக்கு ஒரு அசஸ்மெண்ட் இருக்கு. கடகடன்னு சாட்ஜிபிடியில போட்டு எடுத்து ஆன்சர் போட்டு பாஸ் பண்ணு. கொஞ்சம் அப்படியே கன்ஃபியூஸ் பண்றதுக்கு கொஞ்சம் ரிலாக்ஸா சாட்ஜிபிடி வச்சு நீங்க எக்ஸாம் டைம்ல எல்லாமே சாட்ஜிபிடி இப்ப எல்லாமே சாட்ஜிபிடியில படிச்சுட்டு வரீங்க. எல்லாமே அட்வான்டேஜ் டிஸ்அட்வான்டேஜ் எல்லாம் பார்த்தா அந்த டாபிக் போட்டா அதை எக்ஸ்பிளைன் பண்றான். அட்வான்டேஜ் டிஸ்அட்வான்டேஜ் இதை படிச்சுட்டு வந்து எழுதணும். ஆட்டோமேஷன் ப்ராஜெக்ட் கோர்ஸ் பண்ணா எதுக்கு பண்ணாலும் எனக்கு வச்சுட்டு இந்த பக்கம் சொல்லுங்க மார்ச் மார்ச் 3 year 2 நினைக்கிறேன். வந்து ரிசப்ஷன் கல்யாணத்து வரோம். கால் பண்ணிருக்காப்ல எடுக்கல. அவர் கால் பண்ணவே அதை பத்தி சொல்லுங்க. பண்ண நார்மல் இல்ல வாட்ஸ்அப் தான் அடுத்த போன் யாருக்கு போன கால் பண்ணிட்டு
மேம் சுதா மேம் ஹலோ சார்.
ஹலோ ஹலோ
சாட்டர்டேஸ்ல போவீங்களா ஜிம் இல்ல டெய்லியா?
ஹலோ
மேம் சார்ட்ட சொல்லிட்டேன் மேம், போன்ல சொல்லிட்டேன். சார் உங்களை மாத்திட்டு இருக்காங்க
அவன் அப்படிதான் பண்ணான். ஒரு 2 நாள்
Yes. Then we have successfully reached the conclusion of the 6-day AICT sponsor ATAL online faculty development program on transforming industries with AI, deep learning breakthroughs and real world application. It has been an insightful journey of learning and sharing the knowledge. I warmly invite the participants to share your thoughtful feedback on this faculty development program, as your inputs are invaluable to us. And I request the participant to share your feedback.
Good evening, ma'am.
Good evening, ma'am.
Good evening. This is Dr. Beulah David, working as a professor in Savita School of Engineering, Savita Institute of Medical and Technical Sciences. And it gives me an immense pleasure to give the feedback about this 6 days faculty development program, mainly on this advanced computing techniques on supercomputing, AI, and quantum computing. As we are in this teaching profession, it is must to be get update ourselves to be in the advanced methodologies. So here I have learned many things about these advanced computing techniques, and I thank all the people who handled this 13 sessions really I learned a lot from this computing techniques, even though we know something regarding this advanced computing. And after attending all these 13 sessions, I come to know about the realistic and real-time scenarios, how these things are being used in the industries. And I thank the coordinator, ma'am, Sudha ma'am, for her tireless efforts in making this event. And every time she's giving an alert for attending this sessions. And thank you so much for the entire group of this SRM for making this event to be a fruitful one for all the faculty members. Thank you so much, ma'am.
Thank you so much, ma'am, for your feedback.
Good evening, ma'am.
Good evening, ma'am.
So, good evening, everyone. This is Callens Christiana, Professor and Head, Department of Computer Science and Engineering, SRM Madurai College for Engineering Technology. First of all, I submit my gratitude to Dr. Sudama and Dr. Sindhil Selvi, who rightly coined the topic related to deep learning and design the right curriculum of the FDP, which are highly relevant to the title. The deliverables of the resource person are also highly commendable. With respect to all the 13 sessions, I am saying that, and the contents as well as the deliverable definitely helpful to all the researchers like me who are all developing the application across various fields. Since, as per the statistics of the research, we know that 50% of the machine learning projects are based on the deep learning applications only. And from the first 2 days of the content delivery, I came to know how the deep learning models can be employed in the image retrieval applications, since I am doing the research in image retrieval. And definitely it is helpful to everyone also. Even they are not at all doing the research in deep learning, now they come to the conclusion that how the deep learning can be applied, that is, a convention will be applied to their research in order to make the highlight of this research. Finally, I extend my gratitude to all the resource person and the coordinators for organizing such a wonderful FDP. Thank you, and all.
Thank you, ma'am. Thank you for your valuable feedback, ma'am.
Good evening, ma'am.
Good evening, ma'am.
I'm Radha from working as an assistant professor at Raj College for Women. Um, uh, uh, First of all, I thank all the coordinators for the wonderful sessions, ma'am, because I'm a research scholar. Here's a lot of topics is new to me. I learned a lot, especially explain AI and the real world deployment of AI systems, especially quantum AI. So everything is new to me. I learned a lot and enjoyed. The session handlers know they are explaining very fruitfully, and the organizers also.
I think she has network problem, ma'am.
Yes, ma'am.
Any other participant?
Yes, madam. Am I audible?
Yes, ma'am. Yes, ma'am.
Good evening, madam. I am Dr. Bama, working as Associate Professor in the Department of Computer Science and Engineering at Sri Venkateswara College of Engineering, Bengaluru. I came to know about this program, but the program is very, very nice, madam. All the resource persons delivered the content very nicely. Really, I enjoyed all the sessions. And also, I want to I want to say thanks to the organizers in coordinating all the sessions. Your tireless efforts. I have seen Sudha madam very, very effective. Thank you, madam. Sudha madam, as well as Sethil Salve madam. You both organized the program very nicely. All the participants, even some sessions went even after 9 o'clock also. All the many participants were asking doubts and clarifying it even after 9 o'clock. Most of them are women. Really, I feel very proud, madam. Thank you very much.
Thank you so much. Thank you so much, ma'am, for your valuable
Any other participants?
Good evening, ma'am. This is Dr. Abhijit from Assam Don Bosco University. The entire session was very informative. We have observed many dimensional topics considering the artificial intelligence, deep learning, from the perspective of research and from the perspective of industrial applications. It is very informative. during considering all the 5 sessions. Hope in future also we will be in touch and we'll get such more FDP in upcoming days and years. We will be much more grateful if we can get some kind of e-resources that was discussed by different resource persons, and it will be helpful for our further research work also. Thank you, ma'am. Best wishes.
Thank you so much, sir, for your valuable feedback.
Any other participants?
Good evening, everyone. It is an honor to share my thoughts as a participant after getting these insights in the 6 days FTP. It was really meticulous planning that you have done from your side. The FDP brought together various mindful persons from academia as well as industries, and we have learned so much from them. The only point that I want to share as a feedback from my side, it is all a good one, but the only thing I was missing is the e-content. If you are going to provide that, it will be a very good for us so that we can deliver the same to the students as well as our faculty members. Thank you so much. Thank you.
Thank you, ma'am, for your valuable feedback. We already collected the feedback, the presentations of the resource person. Then definitely we will share it to you. Thank you, ma'am.
Any other participants? Anybody want to?
Any other participants? Any other participants? Okay, Sandil, so we move forward. And thank you everyone who shared your valuable feedback. Your thoughtful words and insights truly inspire and motivate us to continue striving for excellence. And now it is the time for taking the group photo. All the participants are requested to switch on your camera for few minutes for taking the group photo.
It will be very helpful for us. We have to send a photo to AACT. Please, 2 minutes. Everyone switch on your video, please.
Okay, ma'am. Ma'am, you are not audible. Sandil,
One more minute, ma'am. I'll take one snap only and I take another one.
Okay.
Yeah, thank you all.
Thank you all. And as we conclude this remarkable 6-day AICT sponsor ATAL online faculty development program on transforming industries with AI, deep learning breakthroughs and real world application. And it is my privilege to extend a vote of thanks on behalf of Department of Computer Science Engineering, SRM Institute of Science and Technology, Ramapuram, Chennai. First and foremost, our heartfelt thanks goes to our management team, our chairman, co-chairman, chief director, and associate director for their constant encouragement and support which made this FTP possible. I also wish to extend my deepest gratitude to our Dean, Engineering and Technology, Dr. M. Sakti Ganesh, for his guidance and continuous support in organizing this program. His encouragement has been a great source of strength for us. Special thanks to our Vice Principal Admin, Dr. Paliya J. Chellaya, Vice Principal Academics, Dr. Subhashini, and Vice Principal Research, Dr. Rupa, for their motivation and contributions that enhanced the success of this faculty development program. A big thanks to the chairperson of the School of Computer Science and Engineering, Dr. K. Raja, for his unwavering support, and to the heads of department of various departments from SRM Institute of Science and Technology, Ramapuram, for their cooperation and encouragement. I would like to express my sincere gratitude to the chief guest of the inaugural session, the Mr. R. Vairaselvam, Gen AA Solution Architect, Akinjar, Bangalore, for his invaluable insights that set the tone for this program and inspired us with his expertise. I would like to express my sincere gratitude to all the distinguished speakers of various sessions of this faculty development program. Dr. C. Daisy, Professor and Head, Department of Information Technology, Dhyaraja College of Engineering from Madurai, Dr. Anurag Nagar, Associate Professor of Instruction, Department of Computer Science, University of Texas at Dallas, Mr. Sundar Ramamurthy, Principal Data Analytics, Verizon, Chennai, Mr. V. Rajeshwaran, Senior Director, AA Futures and AA Center of Excellence Head, Capgemini, Chennai, Dr. Batri and Subhadi, Associate Professor and Head, Department of Electrical Engineering, Indian Institute of Technology, Jammu, Dr. Lipo Wang, Associate Professor, School of Electrical and Electronics Engineering, Nanyang Technological University, Singapore, Mr. Srinivas Tota, Senior Vice President, Kumaran System, Chennai, Dr. V.D. Ambed Kumar, Associate Professor, Mizoram University, Mizoram, India, Dr. U.S.N. Raju, Associate Professor, Department of CEC, National Institute of Technology, Warangal, Dr. M. Janagi Meena, Professor, School of Computer Science Engineering, Vellore Institute of Technology, Chennai, Mr. M.K. Kumaresan, Cloud Architect, Google India Limited, Bangalore, who delivered enriching sessions over the past 6 days. We are deeply grateful for your time, effort, and willingness to share your valuable knowledge and experiences with us. You have truly enlightened us on the transformative potential of AI and deep learning. To our participants, thank you for your active engagement, thoughtful questions, and collaborative spirit. Your enthusiasm and curiosity made this program vibrant and successful. Lastly, I extend my gratitude to AICTE for sponsoring this faculty development program and fostering the culture of continuous learning and faculty development. Beyond the schemes, I most not forget the efforts of the organizing team, Dr. A. Sindhil Selvi, Professor, Department of CSC, SRMIST Rama from co-coordinator of this FDP program, who worked tirelessly to ensure the smooth execution of this program. Thank you, Sindhil Selvi ma'am, for your fullest support, which greatly contributed to the success of our faculty development program. Thank you, ma'am. Once again, my heartfelt thanks to everyone who contributed to the success of this faculty development program. As we return to our respective institution, I am confident that the knowledge gained here will help us creating a lasting impact in our teaching, research, and industries. Thank you all, and I wish you continuous success in your endeavors. Thank you once again. Thank you all.
Thank you, ma'am. Thank you.
Thank you.
Thank you, ma'am. Thank you, ma'am.
Thank you. Thank you.
Thank you, madam.
Thank you. Thank you, sir.
Thank you, Sudha ma'am, and thank you, Sudhi ma'am.
Thank you. Thank you, ma'am. Thank you, Jana ma'am.
Yes, ma'am.
Thank you so much, Sudha ma'am and Senthil ma'am. Thank you so much.
Thank you. Thank you, ma'am.
And thank you, ma'am.
Thank you, sir.